Hope I am audible and visible.
Yes, you are audible and visible.
Thank you, sir. Hello and good morning to everyone. Na Chaurya Haryam, na Rajya Haryam, na Bhratri Bhajyam, na Chapharakari, Vaye Krite, Varthat Evam Nityam, Vidyadhanam, Sarvadhan Pradhanam. With this ancient shloka about the power of sharing knowledge, University of Engineering and Management Jaipur takes this privilege to warmly welcome all the delegates present here to the first Global Conference on Artificial Intelligence and Applications, GCAIA 2020. My name is Professor Shatabdi Basu from Department of Computer Science and Engineering, and I will be your host for this inaugural session. The aim of this conference is to promote dialogue between scientists, researchers, corporates, and scholar students to mitigate the gap between academia, industry, and governmental ethics. This motivation will be fostered through keynote speeches and oral presentations by eminent researchers in relevant field. In this platform, the academic researchers would expose results and findings of laboratory-based experiments, and the industry personnel will depict cutting-edge research in computer intelligence to convey academia regarding real-time scenario and practical findings. In the next 3 days, there will be talks by industry experts on the state of the art in computer science, lectures by eminent scientists designed to inspire and inform, and presentations by innovative researchers from more than 20 countries. Now, without further ado, I would like to invite our Honorable Chancellor, Professor Dr. Satyajit Chakrabarty, for the inaugural speech. The founder of Institute of Engineering and Management, the University of Engineering and Management, our Chancellor, Professor Dr. Satyajit Chakrabarty, has been immensely influential in inculcating a sense of human values and discipline in students to help them demonstrate their best potential and be a winner in life. With an illustrious education profile from IIT Kharagpur, Professor Dr. Chakrabarty has done commendable research in the field of machine tools, electronics, aviation, alternate fuel, and robotics. Professor Chakrabarty's long career has involved positions as Chief in Charge of Western Region India and as Vice President in British America Investors at World Trade Center, New York, USA. He was also a prestigious member of West Bengal Higher Education Council. Now I would request Honorable Chancellor Sir to deliver his address to the audience. Sir, please.
Thank you very much. It's a privilege to be here and talk to you. Today's Global Conference on Artificial Intelligence and Application is being organized by University of Engineering and Management, Jaipur, and technically sponsored by Springer. We have here from all over the world some of the best brains. Dr. Christopher Neggett, Ulster University, UK, Dr. Thomas Poiter, CEO, Compress Technology AG, Switzerland, Dr. Shiv N. Shai, Senior Vice President AI Platform, Active Intelligence Private Limited, Singapore, Mr. Ankit Sharon, Managing Director, Consulting, Deloitte, Ms. Ajanita Das, Associate Director, AI Analytics and Digital Business, Cognizant, Dr. Sumant Kulkarni, Director and Head of AI Gensar Technology, who has worked throughout the world. Dr. Srinivasa Padmanabhu, Chief Technical Officer and co-founder, City Mondi. Dr. D.P. Kothari, Chancellor, VIT University, Uttarakhand, India. Dr. Kuldeep Singh from MNIT, Jaipur. Dr. Aniruddha De from Jadavpur University. Dr. Arun Prakash, MNIT, Allahabad. Dr. Taposh Shi, NIT, Durgapur. Mr. Amit Kumar Bhairava, MUJ, Jaipur, and Dr. Sandeep Joshi, MUJ, Jaipur, and the professors from UEM, Jaipur, UEM, Kolkata, and IEM, Calcutta. It's a very happy occasion to have such galaxy of intellectuals in the field of artificial intelligence who has agreed to speak and take up a serious work from here. I have two requests to make to this congregation. One is, can we use artificial intelligence to demarcate the boundaries of the countries? I am sure that if we put our head together, we will be finding a solution which will unnecessarily avoid border skirmishes and war and killing of the people. Second thing that I request you is, with artificial intelligence, can we find out the effectiveness of a teacher in a classroom? Because if a teacher is effective, students find it interesting to learn. If the teacher is not effective, students find it boring and they switch off their mind. Now, unless the students learn the subject, and learning is if they find interest in it, then the whole exercise of education will be infructuous. So with these two requests, I will stop here, because the participants are here not to hear my lecture, but to hear the great lectures from the great intellectuals who has come from all over the world. There were around 336 papers which were submitted. Out of that, we could accept 108 papers. And Spinger has kindly agreed to print it in their journal, in their e-journal. Thank you very much. Thank you. Please continue.
Thank you, Chancellor, sir, for your inspirational speech. Sir, you are a beacon of inspiration for all of us, and as always, we look towards you for hope and guidance. Next, I would invite Professor Dr. Satyajit Chakrabarti, Director, Institute of Engineering and Management, Kolkata, and UEM, Jaipur. Professor Chakrabarti is part of many entrepreneurial ventures. His previous role, he was a project manager with extensive experience in planning, execution, monitoring, communicating with stakeholders, negotiating with vendors, and cross-functional teams. He is also a computer engineer with extensive research experience who has created groundwork for Industry University Alliance with Nokia and UBC. I would now request Professor Chakrabarti to please deliver his address.
Thank you, Shatabdi ma'am. Thank you, and I welcome all the delegates to the Global Conference on Artificial Intelligence and Applications. This is certainly a flagship conference of the IMUM group, and we are very, very, proud that so many delegates from all over the world have come to share their ideas, contribute to research, and generate opportunities for all concerned. We all know that AI has been in the forefront of innovation. AI-related technologies, AI-related algorithms are now being used in each and every device. Each and every device is being IoT enabled, and AI algorithms are used. Instead of standard algorithms, these learning algorithms, which can be trained with data and constantly evolving set of algorithms, have performed much better than static algorithms. Okay, so there are so many applications, and I, being an educationist and an entrepreneur, I work with set of teams to create a lot of products in the field of AI. One of the product is I'm doing is text-based analysis for creating various insights, various briefings. One of the products I'm making is financial data analysis, and again creating various insights into the financial reports. So this field is certainly something. 20 years back, when I was in University of British Columbia pursuing my graduate studies, AI field was thought that it is saturated, and that is why I want to tell this story, that the field of AI, I used to ask my seniors, peers, that should I go into artificial intelligence, and they said that this field is saturated. All the algorithms that could have been developed are developed. And at that time, the number of applications of AI were very limited. The most popular one, I believe, was the Dragon AI speech recognition software, and that was also far from perfect. So AI has certainly grown in glamour, in applications, in the number of products that use it, and the ubiquitousness of it. Only now we are thinking, I think there is a school of thought which also thinks that AI is now also saturated. But I think with the IoT devices, there is a big scope for a spurt in growth for the next, I think, few decades. And so this I think should be a flagship conference and a very important conference to give a guidance, a leadership role to the students, that this is the area where there will be a lot of opportunities for product development, and hence also growth, jobs in the next few decades. Okay, so I again welcome all of you, and this will be a very, very exciting 3 days conference. All of you, please attend all the sessions and try to generate a lot of opportunities and identify a lot of new research areas, pockets, and collaborations. Thank you all.
Thank you, sir, for these impactful words. Sir, you have always emphasized on practical learning through guided projects and laid the foundation for industry-academic collaboration in this university. Now, I would like to invite Professor Dr. Bishwajoy Chatterjee, Honorable Vice Chancellor of the University of Engineering and Management, Jaipur, for his address to the audience. Dr. Chatterjee completed his PhD from the National Institute of Technology, Agartala, specializing in nanoscience and nanotechnology. He is pursuing research in the same domain in addition to computer vision and speech processing. He is a well-known name in the field of robotics and has conducted several national-level workshops in robotics. Now I would request Honorable Vice Chancellor, Sir, to deliver his speech. Sir, please.
Yes, thank you very much. Thank you very much, Dr. Chakrabarty. Good afternoon, everyone. It's a pleasure to be here. And I would like to Good morning to you all. I believe I'm audible.
Yes, sir, you are audible.
Okay, thank you so much. So, first and foremost, I would like to welcome on behalf of University of Engineering and Management, UEM, and the Institute of Engineering and Management, IEM. We are welcoming all of you to this platform of Global Conference on Artificial Intelligence and Applications, GCAIA 2020. So this is a 3 days long conference, and in this conference we are going to have several sessions, and these sessions will be organized that there are chairs to the different sessions, so there are different links for attending the different sessions. After my talk is over, I will be posting in the comment box the links or the source of downloading the links for all the sessions so that you can attend those. It's been a pleasure that we were supposed to start the program right at 9:30, but from 9:15 you people have been joining. It was really a pleasure, and it shows that the amount of interest you have taken into this. So thank you so much for all this. Artificial intelligence, what should I say? It is the keyword. It is the word on the basis of which world is progressing. So everywhere we are trying to find artificial intelligence, and at the same time people often ask whether artificial intelligence is going to replace human labor. Let me be very precise, very clear about all this. Artificial intelligence is just an aid to human being. In hotels, using artificial intelligence, robots have been serving food. But then humans are involved in making better things. They're involved in making better food, for knowing the customers better. Artificial intelligence is being used to study the characteristics of a traveler in the hotel industry. But those features are being studied by human being to make the experiences of travelers better. So artificial intelligence is not going to replace human labor. Instead, humans are only going to be aided by this use of artificial intelligence all across. Artificial intelligence is just the imitation of the human intellect exercised by machines. So the world has emerged in the fabrication of new technologies which would reduce human efforts, and artificial intelligence is the way which can show a new path through which authenticity and quality of work can diminish the errors. So as you know, railways, telecoms, airports, corporates have started to adapt this change with the upgradation of technologies and will continue to do so with a more rapid pace. The medical sector is trying to impose this technology to avoid this continuous outrage. Now, this is also important that machines and robots will get involvement in the workforce at a rapid pace, as work from home might be a new work culture. And as I was saying, medical field, there will be a great market for medical robots which can screen patients before sending them over to specific doctors to put them to isolation ward. If required, the humanoid robot could make its way to assign patients with a tray carrying food or medicines, potentially reducing the chances of the hospital staff catching the infection. All this would mean even more scope for robotics and AI. So machine learning, Internet of Things, everything will come in forefront, catching hand of this artificial intelligence in the different machineries of the factories, and will lead the industry, leading to a lot of jobs in this field for computer science, electronics, and other engineers. So I had these things to say about artificial intelligence, but at the same time, I would say it's a good effort from the organizers at the University of Engineering and Management, UEM Jaipur, that you have taken this pain of conducting this conference. I'm sure all these researchers, the teachers, professors, and the industry giants, they will meet together in this platform and they will share their knowledge, they will share their practical work, and through this, we'll get to learn many things. Thank you so much. Thanks to the organizer. Thank you, Dr. Abdi. I will request you to carry on with the conference. People are over here to hear the researcher. Thank you.
Thank you, Vice Chancellor, sir, for your inspiring words. We'll start the day with the first corporate keynote speech by Dr. Srinivas Padmanabhuni, a recipient of the prestigious Eminent Engineer Award by Institution of Engineers at their 32nd annual convention. Dr. Padmanabhuni has vast experience in the computing field, including the marquee area of artificial intelligence. An alumni of IIT Kanpur and IIT Bombay, he is a PhD in artificial intelligence from University of Alberta, Edmonton, Canada, with research interests in AI, machine learning, software engineering, and cybersecurity. Dr. Padmanabhuni is the co-founder of citymundi.com, a next-generation AI-enabled smart B2B startup in agritech, which is focused on farm to fork. And he is also the chief mentor for Tara Technologies, which is an AI consulting and training company. He has been the past president of ACM India and has won several other awards, including the Excellence Award for Innovation at India and Research Excellence Award at the University of Alberta. He is the author of 7 patents and more than 100 refereed international publications, along with being the mentor for multiple startups. Sir, we are honored to have you in this forum, and I request you to deliver the keynote speech titled Exploring the Contours of Explainable AI. Sir, please.
Can I be audible? I'm audible?
Yes, sir, you are perfectly audible.
So can I share my screen? Can I get access to the screen?
Professor Showman, you may kindly stop the screen. Yeah, thank you. So now you can share your screen.
Okay. Okay. So I hope the screen is visible.
Yes, sir, it is visible.
Okay. Let me talk about something which is a very cutting edge topic in the world of artificial intelligence. The whole topic is very relevant because of the reasons which basically defy our natural instinct that AI is a great technology, AI is a great enabler, AI is helping us automate several things. But then there are some issues which have come to the fore. What are those issues? So, start off with a small query. I would like as many answers. Please respond to that. It could be in the chat, or it could be or you can actually speak out. The question is, suppose I have a very experienced robot surgeon who we know has done several surgeries in the past, has been trained extensively on a lot of parts of the body, etc. And we ask him to carry out brain surgery of maybe, let's say, someone close to you, like say your relative. And only thing what we are asked to do is we're asked to sign the form saying that you'll not be given any access to what weapons he's using, what knives he's using, what tools he's using, and you still, based on understanding of his several years of experience, which you know, and the experience of having done on several past surgeries, you have to sign saying that, okay, I will let him do surgery, but I will not be given any access to visibility around what weapons he's using, what knives he's using, whether he's using a hacksaw or he's using a surgical knife. We should not know. Okay, scary scenario, but let me paint that picture. So how many of you would go and, okay, sign that document? Hope all of you understood the question. Okay, more responses. Somebody says he is a mathematician who believes in stats, he would. What about others? There's so many people, 145 people. I would hesitantly, okay, somebody says they would hesitantly. More answers. Put in the chat. So silence means I would say yes, you would agree. So if you had to disagree, you don't want to sign, then please put comment in chat. Not without knowing the details. Good. More. I want more answers. I would not sign without all the details. Oh, many places. That's not a concern. Let's say we assign only one place. Okay. I think I can see many people hesitant to respond. But the fact of the matter is, there is a sense of not signing without knowing the details. And my friends, that's exactly what is happening today in the world of magical AI with very, very complex mathematical, statistical approximations, highly nonlinear things called as deep learning, or highly complex models like support vector machines, random forest consisting of hundreds of trees, very, very complex distributions. So the matter of fact is, today we are allowing tons of AI so-called surgeries to happen in healthcare or in insurance claims or in running your cars or running your vehicles, with many of these models which are black box. And the reason why we are facing this backlash from some of the communities is the very nature of this whole area called deep learning, which is very black box. And the only claim to fame is that it has been proven to be successful in several past data points with high levels of accuracy. But when it comes to transparency, they are zero. So that is where this whole notion of explainable AI came into the picture. So what we see is, today machine learning, deep learning are very much there in almost every business domain. But many times we are asked to trust a model to help us make decisions, but we are mostly dealing with black boxes. But even though these are black boxes, to reduce the concerns of the end users who are deploying such AI systems, it is always a good idea if we can have some understanding of the rationale behind these predictions, or some kind of transparencies into the internals of what they're doing. So analogous to my surgery case, if you can just have access to what kind of tools he's using, what kind of specific incision techniques he's trying to use, it gives a little bit more confidence. So what you need to look at is, in many of these applications, having a two-pronged approach to transparency. One is, if your predictions are backed up by rationale as to why they are behaving the way they are behaving, then more detail is about transparency into their particular model. Both are approaches which are required for making a practical deployment of all these black boxes far more easier. And also one more thing got to understand is metrics like accuracy and some of these typical probabilistic measures are not necessarily a very, confidence giving measures, especially in deep learning with neural nets, etc. So there are issues in terms of transparency, lack of rationale, lack of transparency, lack of fine-grained metrics. All these lead to a lot of issues in domains like insurance, healthcare, transportation, which involves lives. All of these have inherently some issues from trust perspective. So that's where an additional factor which comes into picture is regulatory compliance. A lot of domains in business actually require you to provide a thorough transparency into decision making when you're using the AI systems. Then there are some more issues, like sometimes data which shouldn't be available accidentally can be leaking into training set, and that leads to concerns of privacy and data leakage, etc. So all of these are basically leading you to a need for what we call as an end-to-end explainability. When you say end-to-end explainability into the data, it is important for us to understand that explainability can come in many, many different ways. But before that, the whole rationale for why explainability is required is what I try to present. Rationality is required to improve the trust, handle regulatory compliance as per government needs, get a better rationale if something is not predicting correctly as it is supposed to, and then also visibility into the models itself, right? So we have several kinds of approaches in explainable AI, depending upon the kind of techniques we work with. So what we deal in explainable AI is a whole gamut of approaches, ranging from application of models itself, which are transparent rather than going into complex models, even though it's at the cost of accuracy. Then next is approaching the overall machine learning from a perspective of transparency by giving more visibility into some kind of priorities among the input data or input features, which are giving you a transparency into what feature led to what decision. Then getting a deeper insight into the workings itself of the model itself, like the neural network and how it has behaved as per the image or sound, what kind of network was formed to give rise to the decision. So there's a whole bunch of approaches as part of explainable AI. So rationale for explainable AI is clear. It can be legislative compliance, it can be regulatory compliance, it can be to increase trust, it can be to get a handle into rationale beyond a black box. It can be also about getting an idea of maybe some inherent biases which are crept into data, etc., to get better visibility. So all of that are rationale into explainable AI. Now, what are the different types of approaches for explainable AI? The simplest approach is what we call as keep it simple. It's basically the ergonomic principle of issue, which is keep it simple and safe for the user. When I say ergonomic principles of keep it simple and safe for the user, no better reflection than Apple products. You see, Apple products, they're extremely usable, extremely simple GUIs. They don't have very complex functionality right into the top GUI. A simple, a safe, ergonomically aesthetic use case. So in the machine learning models, we typically have very complex models. It can be a very complex model like random forest, which is a collection of 100 trees, or SVM, which is really an n-dimensional hyperplane separator, or it could be a really, hundreds of weights as part of a multi-layer neural network, especially deep learning. Deep learning is even further more complicated by appearance of further transformations like convolutions and filters. So there is more and more mathematical transformations from the input all the way when you go into class or as you go into an actual value at the output. So it becomes all the more difficult to decode what is going on in the model structure itself. So keep the structure simple and safe. That is the principle of this first category of experiment. So there you see decision trees, or in fact, there are decision rule-based formalisms coming up. Then linear regression. These are two very common categories of algorithms which are simple, yet they are able to give a reasonable transparency into the influence of different input features on the output. So what we do is we look at explainable AI from a perspective of keep it a simple algorithm. Don't worry about complexity of algorithm, even though it's a cost of maybe accuracy. So that is the first category of algorithms, explainable algorithms. The second category, which is also important from the perspective of getting better visibility into a more complex algorithms, like let us say we have a random forest or some of the more complex ensemble algorithms. So what we do is we help get the different levels of importance of the different input features as they are affecting our decision for a particular output. So we want to find out relative importance of each of the input feature for the output. So it may turn out that only top 10% of the input columns are only responsible for all the decisions. So you may want to look at all of those 10 features and come up with, okay, this is the relative feature importance of the different input features as fed into the model for deriving the output. So what we will do is, in this case, we will try to find out the relative importance of the different features which are part of the model. So there are techniques like random forest variable importance factor, or you can use framework like Shapley values, which can help you in deciding different input contributions. Or even there is a neural network based approach called as XNN, explainable neural network, which can help you in determining different important factors for the different input features. So the second dimension of explainability are based on understanding feature importance of each of the input. So the third category, which is very interesting, is what we call as model agnostic approaches. So model agnostic approaches says, let us have model as a black box, fine, I don't care. But I will still try to create some kind of an explainable, imagery or explainable some kind of a technique where I will try to understand how for that particular instance a misclassification took place or how a correct classification took place. So what this kind of techniques like line, which are model agnostic, work on is they take no account of the model itself. So they're model agnostic, model is treated as black box. But what they do is at an instance level for a particular instance, whether it's correctly classified or incorrectly classified, what did they do is they try to create an explanation of the input part, which is responsible for why that decision is taken. So if it's a news article which is read as spam or not spam, it will find out those specific keywords in the news article which will help you determine why it was chosen as spam. Or if it's an image, if it is supposed to be cat but found out as a dog, the reason which parts of the image it construed as leading to qualification as a dog, that is kind of input as the corresponding output when it comes to exposing line for different kinds of input. It can work on structured data, it can work on image data, all kinds of data. What it works on is it takes a very simple idea. It takes the concept of mutation testing. If you know mutation testing and software testing, what you try to do is you take a solution, you mutate it around and try to get small variants of it and see the behavior of the mutants on them. So what this approach does is it takes an overall image or text, converts it into large regions. Each of them could be something called as superpixels or large collections. And for each of them, it tries to perturb around the input and sees the behavior of how the classification output changes, how the particular region is, as the region is disturbed, how the output is changing in terms of the class. And based on that, it tries to form a local approximation of the relative importance or sensitivity to each of these regions, and then comes up with a heat map from the original image or from the original set of words saying that this is how sensitivity was with respect to that part, in that set of keywords or that set of parts of the image. So LIME is an extremely good model agnostic instance level tool. So some other dimension I want to mention is some of these techniques in explainable AI are instance level, where they try to explain individual instance of misclassification or classification correctly done or not. Some of them are global level. For example, the feature importance of random forest is something which talks about a global level across all the examples. This is the order of the features importance. So some of them are global level, some of them are local instance level. So you can see there are 2x2 dimensions of explainability. One is global versus local, instance level versus global across all instances. Second is model agnostic versus model aware. So if you see random forest is model aware, explainable algorithms are model aware because that's looking at the actual model. Then the last one, which is very popular now, especially given the paradigm of deep learning, is this whole concept of can we reverse engineer neural networks and convolution neural networks or deep learning architectures and see and trace the origin of the decision through the network all the way back from the output back to input and pinpoint areas in the input which actually are responsible for the actual decision which took place. So these are what we call as white box, deconvolution based approaches, where we take the opposite approach of convolution networks, where you start from image and generate a class. Instead, you start from the class and work backwards to generate the original images which are responsible for which part of the image is really getting highlighted as a reason for why it is getting highlighted. So the fourth class, which is the white box local instance aware models, are based on reverse engineering the neural networks. So there are different levels of activating them. One could be simple activation maps. They look at what parts of the image are getting activated. Class activation maps are slightly more detailed, but the most details are what we call as GradCam, gradient class activation maps, which actually not only activate with respect to the class, but also activate with respect to the gradient, which has been earlier done. Descent here, you will try to do the opposite and try to come back and reconstruct the original data from which, when slope is applied, you come back to the next layer, which is basically the feature map. So what you do is you try to do the opposite of what a CNN does and try to come back to reconstruct the original image when you're applying the output data. So that way, you see there are four categories: explainable algorithms themselves, then feature importance, typically at a global level by using Shapley values or XNN or random forest variable importance. Then local but model agnostic methods like LIME, which are based on black box but tradition-based approaches. Then we have transparent deconstructing of neural networks based deconvolution methods, which are looking backward from instance output all the way to original inputs. So there you use the basic concept of deconvolution, which is opposite of convolution, and create what is known as gradient class activation maps. So these are the four broad categories of explainable algorithms that are very heavily being researched now. And just to give you some idea of what LIME does, LIME is basically a model agnostic explanation technique whose idea is to explain the result from any classifier so that a human can understand individual predictions. So what it does is it tests what happens to predictions when you give slight variations of your data into the model. So what it does is it generates a new data set, which is permuted samples from the original data like mutation, and then corresponding predictions of the black box model are looked at. And then what we look at is create some kind of a interpolation by weighing the proximity of sample instances and getting a total weighted linear combination, which is given by either a set of feature importances of keywords in a text case or a set of highly important superpixels, which are more important in terms of sensitivity to the model, etc. So what we typically do is we take a instance of interest, its instance level, perturb the data set, get the black box predictions, weigh the new samples according to their proximity to the interest instance, and then create a weighted interpretable model, which is like a linear regression with respect to the variation, and then you create the prediction interpretation. So for example, let's look at this. This is a typical LIME output. So look at the first example. You predicted a dog, but it's actually a cat. So probably there's a part of the image which is basically looking like a dog face here, which is responsible for it. The green area is the one which is responsible for the decision. So predicted dog, but actual it is a cat. So if you see the white part in the green, they're looking more like a dog. So here predicted cat, which is it's actually a dog. Look at the last one. It predicted cat, but it's actually a dog, because looking at the legs and the actual structure, the green area which it has looked at, it is looking like a cat, but actually it is a dog. So in that sense, we are talking about pinpointing the original image for that instance, why it was responsible for the misclassification. We are able to get an idea by using the LIME approach. So just want to show you a couple of more examples. So this is a classical example of the GradCam. So what GradCam does is it looks at the actual model prediction and comes back and gives an actual interpolation of the part of the image which is responsible for why it is predicted as bicycle. So you can see GradCam-like approaches are very precise in terms of pinpointing the exact notions where the part of the image which is actually responsible for contributing to that particular decision. So this is actually done by reverse engineering the convolution and running a gradient on top of it. So we get something known as an activation map. So we have different kinds of activation maps. We get GradCam, we have something called ScoreCam, the different variations of class activation maps, depending upon different ways by which you want to get the deconvolution prioritized. So this kind of approaches, which is the fourth category, white box, GradCam based approaches, are very good in medical imaging, because what happens is if you know specifically some misclassification occurred, we know pinpointedly from the original image what was that which was responsible for the exact output, why it was getting that particular output, so that you get a clear idea of the reason why it took such a decision as to considering as specific class it was identified. So GradCam, CAM, deconvolution, ScoreCam, these are classic examples of the fourth category. So some of the use cases where they are used: medical domain, large firms, Google, Facebook, to detect spam or to detect misuse, banking for fraud detection. These are all examples where explainable AI becomes very important. So as we said, creating explainable model is very critical in these domains, because from a reason perspective, it could be about human readability, which helps to trust the model, justification, interpretability. Also, you may also want to see model improvement possibility if you know why a certain model is not behaving correctly. You get transparency. So that's basically the overall perspective of explainable AI. If you see the three broad dimensions, we can look at either we use explainable AI for prediction, which explains why a certain pattern has been classified a certain way. It can help you in determining what factors of the data has been more important, like I said, variable important. Or you can also look at, from the model transparency perspective, what pattern belonging to the pattern is responsible for this particular look which we're seeing in the model explanation. So these are different dimensions of explanation. So as I said, this is an emerging area, and we're just starting to see tons of approaches along these four areas we saw. And in terms of categorization, I said we could have model specific versus model agnostic, as we saw, right? Model agnostic means treat model as a black box. Model specific means look at the model transparently, like GradCam. Model agnostic means line. Local explainable means explain one instance. Global explainable means globally explain across all instances, like random access variable important. So other approach is ad hoc, which is based on local perturbations like line, or gradient based, which is based on example like GradCam. So some of the very common techniques we already seen based on especially the techniques around the four categories are things like all the variants along activation maps, like deconvolution, guided map propagation, GradCam++, GradCam. They all come under the white box, model aware, reverse engineering convolution network. Then we can also have simple weights visualization as a technique for understanding internals of deep neural networks. Or we can use LIME like black box, or we can use SHAP, Shipley values based variable importance based methods. Or there is emerging techniques where we're talking about understanding a deep neural network by notions of something called as neuron coverage and get better. So with that, I stop my talk here and hope it has been some kind of useful coverage. So we'll be glad to take any questions.
If the audience members have any questions, they can post it in the chat box. I would request the audience members to post the questions in the chat box so that Dr. Srinivas Padmanabhini can answer them.
Okay, so I assume all of you have understood, and so it shows which area it considers, but can it tell what it is extracting? What it is extracting ultimately is only a class. So when you are extracting a class corresponding to a particular cancer's detection, it will just say, is it cancerous or not? But when you want to get more details, goes back and tries to find out, localized by doing deconvolution, finds out which actual area is responsible for it telling the scans. For the first robot which is based on AI, I think a robot has been very, very old area. So I would say even the first Turing machine, which was invented by Alan Turing, that itself was a robot in my view. So I don't think technically there's something called a separate thing called a robot. As time goes by, will humans stop to think? I don't think so. Because let me tell you, today in the world of artificial intelligence, we have 3 grades, something called weak AI, narrow AI, then strong AI or general AI and super AI. But today we are only doing weak AI or narrow AI, where all the intelligence is coming from deep learning, neural networks, etc., where tons of data is fed to it after labeling, and only then is discovering a pattern. And then that is what it is. Today's AI is purely a pattern matching exercise. It is not even 1/100th of what a human brain can do. So I think humans are still on the top. AGI or general human level intelligence is at least 30, 40 years away. So don't worry. Electrical branch faculty, how we can update in this direction? Just, I would say, simply go and search on machine learning in any YouTube channel. You have lots of training material, or go to, Coursera or Udemy, enroll on end-to-end course on machine learning or deeplearning.ai. Very good. So can you highlight prospects of IoT and explainable AI in healthcare? Already I've told you, explainable AI in healthcare is very important from the perspective of we are doing cancer detection. You know where to look for, why to look for, what pattern to look for. But IoT is all about sensors. Today there's a lot of applicability of sensors and of smart healthcare. So what we can think of is, especially talking about really simple sensors we're trying to devise, which can detect many body factors like temperature, blood pressure, BP, etc., all with simple contactless sensors. So a lot of work is happening on how you can develop very good diagnostics with very simple IoT devices. So, sir, is it learning or just remembering? Because we just see more the data, the better it classifies. In deep learning or machine learning, there is no remembrance. It's all about extraction of patterns. So once, suppose you have a model from existing set of 1,000 images, and you get a new set of 10 images, and you want to update the model, you cannot do it. You have to go and retrain with 1,010 images. So there's no concept of learning, remembering. It's all about highlighting patterns from data. Explainable AI differs from image captioning problem of deep learning. Image captioning is something like toy. It just takes the image and converts them into text. But what explainable AI does is it does extremely proper, focused, sensitive rationalization of the actual components of the image which are responsible for that particular decision. So they are absolutely different things. Image captioning is a toy. It does not help anything. It's only for demonstrations. Practically, explainable AI needs far more precise pointing to image parts, which is helping in taking the data. How relevant IoT AI synergy? Today, IoT generating tons and tons of data at high volume, high velocity, and there is very little value if you cannot add analytics and AI on top of it to take actions, whether for smart building, smart medicine, smart electrical, smart transportation, smart sewerage, smart water, smart agriculture. All of them is about making use of the sensor information and get important insights from there. Any other questions?
Sir, I think we can wrap up the Q&A session. I think you have
Thank you.
all answered all the questions.
If explainability is strong, can we create an AI that creates an AI given proper explanation? I think work is on, but it's still long way to go when you want to have AI creating AI. There is some work going on, but it's still a long, long way to go. Thanks a lot.
Thank you, sir. Thank you for these new insights into the field of artificial intelligence. I'm sure the audience members have greatly benefited from your presentation. And we were honored to have you in this conference, sir. Thank you for joining us today. Now, for the first research keynote speech of the day, I would like to invite Professor Dr. Kuldeep Singh of Malviya National Institute of Technology, Jaipur. Dr. Singh is the recipient of R&D Excellence Award from Bharat Electronics Limited in 2009 and 2011, and is also reviewer of various IEEE transactions, Elsevier, and Springer journals. He received his PhD degree in computer vision from Delhi Technological University and worked as postdoctoral fellow at University of Alberta, Canada, where he was involved in the development of deep learning based functional prototype for agriculture applications. Before joining MNIT, he worked at Central Research Laboratory of Bale Ghaziabad as scientist, where he was involved in various software development projects of national importance. Now I would request Professor Dr. Kuldeep Singh to deliver his keynote speech titled Deep Learning for Applications. Sir, please.
Thank you, Dr. Basu. Thanks for the nice explanation of my biodata. Thank you. With this, good morning to all participants. I'll be talking about the deep learning applications in the field of medical diagnosis. So with this, I'll share my presentation. So, given the limited time of half an hour, I'll only be discussing these topics related to deep learning application in the field of medical imaging or medical diagnosis. We'll briefly discuss about what exactly is deep learning and how it is different from traditional machine learning and artificial intelligence. We'll have some footfalls of deep learning in field of medical applications. We'll discuss some of the test cases where deep learning has been extensively utilized in the field of medical diagnosis. We'll talk about how we can build models. There are some inherent challenges while building the models for medical applications. We'll also discuss about how we can test and evaluate the models. So the basic question arises is, what's the basic difference between AI, ML, and DL? I'll briefly talk about it since it is a relevance to this particular conference. Artificial intelligence, which dates back in 1950s or 60s, that time the main sole objective of artificial intelligence to mimic the human behavior, to transfer the way human perceives the things onto the computer. Can a computer do the task which a human can easily accomplish? So that was basically artificial intelligence. Well, it was mainly through the software programs, framing some kind of rule engines. Fuzzy logic was also one part of artificial intelligence at that time. So this was basically decision. It was helping the computers to make a decision the way a human does. So it was purely based on programming the computer, transferring the human knowledge in terms of programs, in terms of rule engines to the computer so that it can mimic the human behavior. That was the limitation of traditional artificial intelligence. Then came machine learning. in machine learning, it also says it's the ability to learn without explicitly being programmed. That means we need not to program it explicitly. The machine learning techniques, algorithms should have capability of learning from the examples. Uh, it has to extract some kind of meaningful information from the given data and then learn from it. Instead, the way in artificial intelligence we have to program specifically, we have to transfer the knowledge of the human to the computer uh, in terms of programming or some kind of rule engines. But in machine learning, we need not to program explicitly to the computer. Deep learning, which is a recent advancements in the machine learning, also it is advanced form of neural networks, and we achieve the task. Deep learning doesn't have an explicit task of extracting features and then classifying that data, but deep learning is meant for extracting meaningful patterns from the underlying data. So that's the basic difference between AI, ML, and DL. What exactly is deep learning? Deep learning is for extracting useful patterns from the data. How it is accomplished? It is accomplished using neural networks and advanced optimization techniques. You must be aware that neural networks were invented in 1950s and neural networks are inspired the way human brain works. But it has become popular in recent times. So thanks to the recent optimization algorithms, which has made it realizable in the practical terms. Then why now? The major reasons behind the popularity of deep learning in recent times is threefold. One is the availability of big data. The neural networks or deep neural networks, these algorithms are data hungry algorithms. They need a large volume of data for training of the different layers of the neural network. So with the availability of large volume of data sets these days, one example is the ImageNet data set, which is meant for image classification, which has millions of images. And most of the modern deep learning convolutional neural network architectures were initially trained on ImageNet data set. Then availability of hardware. You must be wondering that in 1950s, 60s, when neural networks were invented, the major drawback behind that was the non-availability of hardware to train those large neural networks. Now, thanks to the GPU's graphical processing unit, we can easily train uh, any deep neural network within a frame of seconds. So that's the availability of hardware which has made deep learning practically realizable in our daily life. Also, the availability of softwares, open source softwares like TensorFlow from Google, Caffe, Keras. So these type of softwares are available freely for the researchers. They can they can make deep learning based systems using these open source softwares. So what exactly is deep learning? In comparison with conventional machine learning, the conventional machine learning pipeline involves you have a input data, whether it is the audio data or a image data. You have a dedicated step of feature extraction. Then finally a prediction model. The prediction model can be of a regression model or a classification model. It can be supervised or unsupervised model. However, in deep learning, we don't have a dedicated feature extraction step. Uh, the feature learning or it is not feature extraction. In the term of deep learning, we have feature learning. The deep learning model is capable of learning features from the data, input data. We need not to extract specific features to a particular domain. Deep learning models are capable of doing that. These models work the way our human brain works. Deep learning are inspired from the human brain. The neural networks are inspired the way our human brain works, process the information, and the brain takes collective decision based on the inputs available to the brain. Similarly, deep learning is also able to extract meaningful information from the underlying data and then perform prediction on it. So one of the popular models, one of the popular algorithm or architectures of deep neural network is convolutional neural network. it is a hierarchy of layers, and we have different type of layers, and each layer has its own working. Like convolution layer, convolutional neural convolution layer, it is capable of it has to extract features out of that image, whether if the input data is the image. So different type of filters are applied all across the image to extract some meaningful patterns out of that image. Then we have rectified linear unit, ReLU. This is a nonlinear activation function, which is a decisive layer. It brings nonlinearity into the system, since the practical examples, all the practical examples are nonlinear in nature. So that's why we need some kind of nonlinearity into the system. That is brought by rectified linear unit in convolutional neural network. Then we have pooling. Pooling is basically a dimensionality reduction layer which reduces the dimension of the input data. You can see the size of the cube has reduced after passing through the pooling layer. So that's the pipeline of the convolutional neural network. That's the hierarchy of different layers, and every layer has a unique way of processing the information and passing this information to the subsequent layers. As the input image passes through this hierarchy of layers, it is finally comes and it is flattened and it is passed through the fully connected layer. And finally, we have a classification stage where we can apply a softmax layer. The softmax layer is a probabilistic classifier where if the value of the probability is greater than a particular threshold, then that particular node is activated. For example, the node corresponding to the car in this particular example will be activated, will have the highest probability, highest output score in the softmax layer. And the task of the softmax layer is to find out which node has the highest value. So the input will be classified to that particular. Let's talk to the theme of this presentation, where we'll talk about deep learning presence in the medical domain. It has deep learning specifically, which was earlier shown promising results in the field of computer vision, specifically in image classification and object detection. But nowadays, it has been extensively utilized in the field of medical domain, whether it is discovering new antibiotics. Discovery of antibiotics is a very complex task, and researchers end up in discovering the same antibiotic again and again. Deep learning specifically has shown surprising results in the field of antibiotics or drug discovery. There are major companies which have investing too much of money applying modern AI or deep learning algorithms, and specifically in medical domain. Google is extensively working in the field of medical applications or automating the medical diagnosis with the help of artificial intelligence or deep learning algorithms. Google uses artificial intelligence to detect breast cancer by screening the mammograms of breast. It can detect the cancer out of it. Deep learning has also been deep learning based tools has also been developed to accurately identify common eye diseases. Recently, in the pandemic times, radiologists use deep learning to find signs of COVID-19 in chest X-rays. At MNIT Jaipur, different research groups have also been involved in applying deep learning or artificial intelligence-based algorithms in the field of medical domain. We are also uh, able to apply deep learning for finding COVID-19 from the chest X-ray. We are extensively working in close collaboration with SMS Hospital Jaipur and RUHS Hospital Jaipur to make a cloud-based solution using deep learning to detect COVID-19 from the chest X-rays. There are other test cases, use cases of deep learning in the field of medical domain. There is a famous startup in the field of medical diagnosis. It is Analytics. It's a US-based company. It has invented a device which has surpassed the combined abilities of a group of expert radiologists at detecting lung cancer nodules in CT images. And surprisingly, the performance is 50% higher than the testing conditions. Similarly, the Google's has developed a lymph node assistant which is able to detect metastasized breast cancer from the pathology images with 99% success rate. And you will be surprised that where the human doctors have scored as low as 38% performance or accuracy in particular domain. Uh, there is a uh, AI doc based software uh, which has been installed in more than 100 hospitals worldwide, which helps the radiologist to diagnose the radiology images, to analyze the radiology images. So let's take, considering the current scenario, let's take a real life example of how COVID-19 can be detected with the help of chest X-rays. Uh, with, with the help of chest X-rays, a model or algorithm can be trained, and it should give us the output as whether this chest X-ray belong to a COVID-19 patient or a normal pneumonia patient, or it's a normal chest X-ray. With the scarcity of this RT-PCR based test kits, and we this could help the radiologist or medical practitioners to develop an alternate testing strategy for detecting COVID-19 people. Similarly, there are other applications like diabetic retinopathy. It is basically related to the damage to the blood vessel of retina, and sometimes it can lead to vision loss. The diabetes patients have a tendency to develop diabetic retinopathy, and that's why they are regularly advised to have a eye checkup. So, in this particular analysis, a retinal fundus image is captured, and this has been analyzed by the models or algorithms, and the output will be whether the blood vessels of the retina are damaged or they are not. Another extensive application of deep learning has been in the field of MRI images. One example is brain MRI segmentation, where you must be aware that the MRIs are a high resolution data, and considering different slices of MRI, it's a large volume of data, and a lot of information has to be processed from these MRI images. So MRI segmentation plays crucial role in diagnosing different images, different type of diseases, brain-related diseases. So, MRI segmentation with the help of deep learning can help the radiologist to diagnose different type of diseases. The different type of brain consists different type of matters, and based on the volume of these matters, whether white matter or gray matter, so based on the volume of these matters in the brain, different type of diseases are diagnosed. Similarly, segmentation of tumor in MRI images can help in detecting cancers. So that is also one of the applications where deep learning is extensively being utilized for MRI images in detecting tumors. Another applications where deep learning has been extensively utilized is histopathology images. Histopathology images are basically microscopic images of blood smears, and this analyzes the tissues in the blood where the pathologist basically diagnose whether the given histopathology images contains a benign or a malignant. Malignant means it's a cancerous cells are present there. So that's where deep learning algorithms has been extensively utilized to detect cancer from histopathology images. Uh, these were some of the use cases of deep learning in the field of medical images. Other applications are prediction of medical events like seizures and cardiac arrest. Seizures, by analyzing the EEG signals, the prediction of seizures can be done with the help of deep learning algorithms. Similarly, though the accuracy in predicting the cardiac arrest is not that high, but yes, uh, researchers are working on this field where they have applied deep learning algorithms for diagnosing cardiac arrest. Drug discovery, we have already discussed. Analysis of electronic health records, automated medical report generation. That's also an interesting field where by seeing the chest X-ray, the deep learning based algorithm can generate a automated report which can be handy for the radiologist as well as the doctors to diagnose the X-ray. Alzheimer disease detection, cyst segmentation. Another very interesting application is pharmacogenomics, where this is a study related to the genomic variation that affects a patient's response to a particular medication. And the list is endless. It has shown promising results in each and every aspects of medical diagnosis. So let's deep dive more into how we can detect COVID-19 with the help of chest X-rays. In this particular slide, you are given with 3 examples of each COVID-19 patients as well as normal. If these images are shown to an expert radiologist, he must be able to establish a similarity between the given set of COVID-19 chest X-rays as well as normal. If a new set of chest X-ray is given to the radiologist, he must be able to identify whether this chest X-ray belongs to COVID-19 patient or it's a normal chest X-ray. Similarly, the deep learning models can also be trained by giving some examples of 2 classes of COVID-19 and normal patients, and then finally, whenever a new chest X-ray or chest X-ray is given to that particular model, it will be able to identify whether what kind of chest X-ray it is. So let's discuss about how we can build models. So we have to supply, as I have told you, uh, it's a data hungry models. Deep learning or deep neural network based models are data hungry models. So thousands of chest X-ray images are given uh, as an example to train these models. These models can be deep learning, neural network, convolutional neural network. We call them with different names. So they learn from the examples. We give them labeled data set. Labeled data set means the particular chest X-ray has a label, whether it belongs to what kind of class, whether it belongs to COVID-19 or it's a normal pneumonia or it's a normal chest X-ray. So these models learn from the examples. Learn from the examples means these models will give the output in terms of prediction probabilities. By given an example, they will start giving some kind of score to a particular chest X-ray. In this case, suppose it has given for the COVID patient, the desired level should be 1, but it is giving us 0.42. And in the case of normal chest X-ray, it is the desired level is 0, but it is giving us 0.59. So it's in the starting stage of the training where this model is giving us very erroneous results. So the task of the training is to train the model in such a way that outputs are very close to the desired levels and error is very low. We can, with the help of these given prediction probabilities and desired levels, we can calculate the loss and error. And the task of the training or building these models during the training is to minimize this error. This error should be as close as possible to 0. And the output prediction probability should be as close as to the desired labels. So as we apply the training process and with different large number of iterations, the loss becomes close to 0 and the prediction probabilities becomes close to the desired labels. Similarly, in the field of histopathology of images and also in MRI images, the uh, images are of high resolution. So high resolution means one histopathology image might be of 1 GB. So processing this large image is very difficult task if we consider the convolutional neural network or deep neural networks. So the better idea is to sample different patches, and instead of assigning label to the complete image, we can assign labels to these patches, and the model can be trained on the patches sampled from the complete page. There are different CNN architectures like Inception V3, ResNet 34, DenseNet, SqueezeNet, different type of CNN architectures has been applied in the field of medical diagnosis. This is the typical example how input image, different patches are extracted and convolutional neural network is being applied. Finally, it passes through the hierarchical structure of convolutional neural network, and finally we get an output. We'll discuss one of the challenge, we call it data side challenge. As you are aware that getting proper data, medical data is a big challenge itself. So creating a data set and having a large volume of images in that data set itself is a challenge. So in the field of deep learning, we have solution to this data side challenge. In fact, if we have a smaller number of images in the data set, we can also work using deep neural networks. And the technique we refer here is the transfer learning. Also, we call it fine tuning of the brain network. The idea is the convolutional neural network is pre-trained on some other data set, and then what we can do, we can take that pre-trained net and then do fine-tuning using a smaller data set of medical images, and finally we can use this convolutional neural network in the medical domain. The idea is basically of transfer learning. We transfer the learning which has been learned in the form of pre-trained connects. The basically, as I told you, convolutional neural network processes the information, input information in a hierarchical way. So the starting layers, the initial layers are responsible for extracting lines and edges from the input image. And extraction of line image is similar for whether they are images of dogs or cats or whether they are images of medical modalities. So that's why the starting layers can be used from a pre-trained network. Only the last layers where they are responsible in deciding the crucial factors or extracting the crucial information from the medical modalities, only those layers can be trained with the smaller data set. Another solution is data augmentation, where we can create new images from the existing images, and there are different ways of creating that, like we can use zoom, flip, translate, and combination of these techniques. We can rotate it, we can increase or decrease the data set. Next comes the testing the models. So the complete data set is divided into three sets. One is training, one is validation, and another one is testing. So training is basically for development, validation is for tuning of the parameters, and then testing is for the performance evaluation of the trained model. It also has different challenges like patient data overlap, annotation of ground truth. So the challenge of patient data overlap is basically the idea here is we should have the data from a particular patient in one type of this set, whether the data should be available in training or validation or testing. It should not happen that we include the data in one data from a particular patient in one set and then in the another. In that scenario, we'll have over optimistic performance, and there might be possibility in this example. You can see the chest X-ray includes a necklace here. So the model will memorize that necklace as the feature of the normal patient. So it might happen that if a person with a necklace is coming for a chest X-ray, and if he is wearing a necklace, then it might be possible whether it is having some kind of complications in the chest X-ray, but it may be classified as a normal patient. That's a vague example, but however it happens. The deep neural networks are famous for memorizing some unique information from the input data. So ideally, no overlap of patients in the different data set. That's why we assign patient IDs as well as image IDs to the images, chest X-ray images. Another problem is ground truth annotation. For training the data sets, training the convolutional neural network for deep learning models, we need labeled data set. Labeled data set means for each input sample, we should have a particular label, whether it belongs to a benign class or a malignant class. class. So even the pathologist or radiologist have a difference of opinion. So the solution is consensus voting. We can uh, we can have a consensus voting of different set of radiologist or pathologist while labeling these data set. Another way of solving this problem is use another modality. Instead of pathology, histopathology images, we can use MRI images for detecting, for labeling that data set. Then we have evaluation of models. So one way of evaluating, one metric for evaluating a model is accuracy. There are different uh, metrics for evaluating these models. We call them sensitivity, specificity, then receiver operating curves, ROC. So these are different parameters or metrics by which we evaluate the models, how efficient these models are. As you can see here, there is a table here where we have ground truth and model output, and this table is called as confusion matrix. So like the true positives are they any chest X-ray which is detected as diseased, it is labeled as diseased, and the model is also giving the output as diseased or positive. So that case is true positive. So based on this confusion matrix and different parameters matrix available in this confusion matrix, we calculate other parameters like sensitivity and specificity. Another one is the ROC curve, which is also another graphical way of evaluating any model. Let's talk about some data sets. There are different data sets which are publicly available for research purpose. Like in the case of MRI, there are famous data sets such as Open Neuro, UK Biobank, ADNI, Alzheimer's Disease Neuroimaging Institute. Similarly, in the case of chest X-rays, we have Chest Expert, Chest X-ray 14, histopathology images. We have sets like MITOS, PECHIS. These are the different data sets. Let's summarize what exactly we have discussed in the last half an hour or so. We talked about convolutional neural network. I gave you the example how the information is processed hierarchically by different types of layers, and every layer has a different task. Then how do we build models? We talked about the challenges of data size, and there are two solutions of data augmentation, transfer learning, where we can have a pre-trained deep neural networks on a different data set, and then we can fine-tune it on a smaller data set of medical abilities. Then we have testing of models. We talked about challenges like there should be no overlap of patients in different sets. Then we talked about different metrics of evaluation of the models. So sensitivity, specificity, and others. Thank you. Thanks for your attention. If you have any queries, please let me know.
I think, sir, there is one query from Vijeta Sharma.
Yeah, tell
How
me.
asymptomatic COVID-19 can be detected? I
How
think
asymptomatic COVID-19 can be detected? As you are aware, the AI, machine learning, or deep learning based techniques are basically based on the features. So if the features are not available to these algorithms, I'm really doubtful that these algorithms will be able to detect asymptomatic patients. Though this domain is specific for the doctors and medical practitioners, I won't be able to specifically answer how to detect asymptomatic COVID-19 patients. But yes, with the help of deep learning and medical machine learning algorithms, we need specific labeled data set where we can differentiate between a normal patient and a symptomatic patient. So that kind of data should be available.
Thank you, sir. If the audience members have any more questions, they can post it in the chat box so that Dr. Singh can answer them. I would request the audience members to post their questions in the chat box for Dr. Singh. So I don't think any more questions are forthcoming. So I think we can wrap up the. Okay, there is one. One-shot learning or zero-shot?
Yes, they are very much relevant in this field as well. One-shot learning or zero-shot learning is definitely they are suitable for medical applications for deep learning. This is specifically applicable where the data is not much complex. But yes, definitely these type of learning methods can be applied in the field of medical applications.
Thank you, sir. Thank you, Dr. Singh, for delving into this very interesting and relevant topic in medical domain. We were honored to have you in this forum today, sir. Thank you so much.
Thank you, ma'am. Thanks a lot. Thanks a lot for inviting me for this conference, and I wish a very great success for the conference. Thank you.
Thank you, sir. For our next speaker, Dr. Arun Prakash is an associate editor of IEEE Access and a guest editor of Journal of Computer Networks and Communications. A PhD from Motilal Nehru National Institute of Technology, Allahabad in 2011, Dr. Prakash is presently working as an associate professor in MNNIT, Allahabad. His research interests are in the area of wireless and mobile communications, ad hoc networks, vehicular networks, cognitive radio networks, and wireless sensor networks. An author of more than 50 papers in international journals and conferences, Dr. Prakash has also served as program committee member of several international conferences in the area of wireless communication and networking. I would now request Dr. Prakash to deliver his address on spectrum handoff in cognitive radio networks. Sir, please. Hello? Hello, Dr. Arun Prakash.
Professor Shoman, you may kindly contact Dr. Arun Prakash over phone. He might have lost internet connection at the moment. So if you can kindly contact him quickly.
I think I can see sir in this meet as a participant.
Professor Shoman, are you there?
Good morning. How are you, madam? Fine, thank you. You have not sent my money yet?
There.
Right.
Dr. Arun Prakash, if you are there. Hello, Dr. Arun Prakash. If you are in the meet, sir, if you can just start with him. Hello.
Hello. Actually, he is facing some connectivity issue. He will be coming in a while. Okay.
Okay. So we will wait. Yes.
Oh,
Professor
yeah.
Shoman, you may kindly tell him to leave the meeting and join again if he is facing some
I
problem.
have already told that.
Okay.
Okay.
Thank you so much. Thank you.
Hello, am I audible to you?
Yes, sir, you are audible.
Yeah, very good morning. I am very sorry. There was some problem in my microphone. So, good morning to all of you.
Mention not, sir. You can carry on, sir.
Yeah, please. So I'm here. I'm going to share my slides. I hope the slide is visible to all of you.
Yes, sir, it's visible. It's
Okay,
perfectly
fine.
visible.
Okay. So the title of my today's talk is Spectrum Handoff in Cognitive Radio Networks. So here in this presentation, so I have divided it in two parts. First, I will try to discuss the cognitive radio networks, about the cognitive radio network, and then I will come to a specific issue of cognitive radio network, that is spectrum handoff in cognitive radio network. So let us start with the motivation behind this cognitive radio network. So as we all know that the current fixed spectrum allocation policy that is done by the government agencies is unable to accommodate the growing demand of the wireless network. So hence this problem of spectrum scarcity and inefficiency in spectrum usage is there, and therefore cognitive radio networks are developed that are providing high attention to wireless community, which allows the dynamic use of the underutilized spectrum. And the dynamic use of the available unutilized spectrum can be done by spectrum handoff, which is the main part of this talk. So this talk basically presents a comprehension about cognitive radio networks in general, with the emphasis on spectrum handoff schemes for cognitive radio networks. And upon the discussion over the available spectrum handoff schemes, I will also try to present various research issues and challenges in this area. So let us start with the motivation behind this cognitive radio network. So as we can see in this slide, that the exponential growth in wireless networks has raised the demand of extra spectrum bands. So according to Cisco, the mobile data traffics are expected to have threefold increase from 2016 to 2021. But the current wireless networks are bound with fixed spectrum allocation policy, which, as I said, is being regulated by government agencies. So the current fixed spectrum allocation policy is unable to accommodate the growing demand of the wireless network. In fact, some of the allocated bands are underutilized, which we can see from here, that most of the bands you can see are underutilized. So here this shows that the spectrum uses are very, very low. And this second figure basically shows the spectrum occupancy at different locations of USA. So here you can see that for different applications, the allocated band is not fully utilized. So rather there are many spectrum holes or white spaces. So sometimes we call it as the white spaces, as you know. So if you see this figure, so it will be more clear. Here I have shown some 5 networks. So this is network architecture. So basically these vehicles are termed as nodes, nothing else. So these are nothing but mobile nodes. And here there are many networks, WiMAX, some Wi-Fi networks and UMTS networks. So here you can see that some networks are lightly utilized networks, some are moderately utilized networks, and some are highly utilized networks. So this is because of the fixed spectrum allocation policy. So the available bandwidth which is not used is we call it as spectrum holes or white spaces. So as per US FCC, that is Federal Communication Commission, most of the allocated spectrum is underutilized. basically because of fixed spectrum bands. So this causes a large gap between the current increased demand of extra spectrum bands and free spectrum allocation policy. So then to overcome this, the CC suggested using the underutilized spectrum and spectrum portions which are not in use, which are called as vacant spectrum bands or white spaces or spectrum holes. Now this is known as dynamic spectrum access, through which unlicensed devices can use the licensed bands. So the concept of dynamic spectrum access is to accommodate the growing demands of wireless networks and to solve the current wireless spectrum inefficiency problem. So, so this is the motivation behind this cognitive radio technology. And as you can see here, that if a node wants to communicate to another node, and if that particular path is congested, that means the communication cannot be established. So through the cognitive path, that means the new path, the communication can be established through other channels, through other available channels. So by the use of cognitive radio, this congestion problem can be resolved. That is another motivation. Similarly, in 5G new radio, there is a lot of scope of cognitive radio, because the band which is available is from 1 to 6 gigahertz, and it is extended up to 100 gigahertz. So there is a diverse spectrum and diverse applications. So there is a lot of scope of cognitive radio technology in 5G also. Then in automation of different things, cognitive radio technology can be used. That means some cognitive radio algorithms can be proposed. That means some automatic algorithms that can recommend the actions based on the gathered information instead of doing it manually. So we can go for automation also using this cognitive radio and using SDR, that is software defined radio. So now, as far as definition of cognitive radio is concerned, let me first tell you that the concept of cognitive radio was first introduced by Joseph Bitola in 1999. So here if you see this definition, it is the cognitive radio. A cognitive radio is an intelligent wireless communication system which is evolution of software defined radio that can sense, analyze, decide, adopt and communicate based on interaction with the environment in which it operates. So this is the definition. So from this definition, we can say that the cognitive radio has two main characteristics. The first one is cognitive capability, through which it can capture or sense the information from its radio environment. That means the portions of the spectrum that are not in use at a specific time or location can be identified, and consequently the best spectrum and appropriate operating parameters can be selected. Second thing is reconfigurability, through which it can change its parameters according to the environment. And the reconfigurability is provided by a platform which is known as SDR, upon which this CR is built. So SDR means software defined radio. So here, if you see in this figure, basically I am trying to represent a non-cognitive technology. Okay, so in non-cognitive technology, what happens that the mobile nodes are here you can see that the cars are nothing but the mobile nodes. So these mobile nodes are using different frequency bands of the networks, of different networks. So here you can see that the cognitive radio allows the nodes to switch from one network to another, meaning thereby if this network 1, for example, is a congested network, so it can use the channels of network 2 So that is through cognitive radio technology. But if there is no cognitive radio technology, that is non-cognitive radio, then this functionality is not possible. So even if there is congestion, it cannot switch to the channels of other networks if it is a non-cognitive radio technology. So that means the increased number of increased traffic cannot be handled by non-cognitive radio technology. So that is why in the next generation networks, we are bound to go towards cognitive radio technology. Then this figure basically shows the fixed spectrum allocation policy. So as I said earlier, that the fixed spectrum allocation policy is regulated by government agency. So due to the fixed spectrum allocation policy, some networks here, for example, network 1, are highly utilized frequency band, where some networks are lightly utilized, for example, network number 2, and lightly utilized and underutilized. So we can say network number 3 and 4 are lightly utilized, while network number 2 is you can say underutilized network. So it can be observed that network 1 is highly utilized, where congestion in the network may occur, this one, whereas network 2 is underutilized frequency band. So here you can say that you can see that spectrum holes exist. There are large number of spectrum holes in different networks, and those spectrum holes are called as void spaces. So here we show the dynamic spectrum allocation policy that is used for cognitive radio technology. So these unused holes, which I have shown here, or void spaces, can be utilized with the help of dynamic spectrum allocation policy for cognitive radio technology. So basically this figure shows that dynamic spectrum allocation policy where nodes of one network are allowed to switch to other networks. Nodes of one network are allowed to switch to other networks to use its unused frequency band. And hence the demand of extra spectrum band of current wireless networking can be solved with the flexible use of unused frequency band. So that is dynamic spectrum allocation. Then here I am trying to present the network architecture of cognitive radio network architecture. So it basically shows that there exist two basic type of networks. One is termed as primary network. So here there are two primary networks, and the second is the secondary network or the cognitive radio network. So these two are cognitive radio networks. Obviously, one is infrastructure-based cognitive radio network, and the other is without infrastructure. That means infrastructure-less cognitive radio network. So the primary network is the licensed network, which has an exclusive right to use the certain spectrum band. So the base station and different nodes here in the primary network are known as primary network base station and primary users respectively. So we call them as primary users, which have dedicated spectrum. So CR networks can be classified, as I said, as infrastructure based or infrastructure less cognitive radio network. And the cognitive radio network, it may use the unlicensed bands or the primary user vacant license bands without having license. So this is basically the architecture where there is primary network, secondary network. So the nodes in the secondary network can use the channels of primary network. So when the channel is free, That means when the primary user is not using the channel, then it can be used by the secondary. And second thing which is very, very important, if secondary is using a channel of primary, and as soon as the primary comes back, then secondary has to abort its transmission immediately. So it has to vacate the channel, because it is mainly dedicated, it is a dedicated channel for the primary user. So this is the cognitive radio network architecture. Then this is network spectrum management framework, cognitive radio network management framework. So here you can see it is broadly divided into 4 parts. First is spectrum sensing, then spectrum diffusion, followed by spectrum sharing, and finally we have spectrum mobility. So the first step starts with spectrum sensing. So this sensing deals with detecting the unused channels in cognitive radio network, and cognitive radios identify the available spectrum bands, their information, and detect the unused spectrum holes. And the main function of spectrum sensing are primary user detection and sensing control. So primary user detection identifies the presence of primary users in the channel, and sensing control involves how fast cognitive radios identify the available channels with sensing accuracy. So there are many spectrum sensing schemes which are available in literature, including the waveform based sensing, radio identification based sensing, match filtering, and so on. So there are many such schemes available. Then we have spectrum decision. So this part deals with selection of the spectrum out of the available spectrum. So these available channels are identified by the process of spectrum decision. And the main function of spectrum decision include spectrum characterization, spectrum selection, and reconfiguration. The spectrum hole is characterized by the received signal strength, interference, path loss, and number of primary users using the spectrum. And the spectrum selection function includes selecting the best spectrum out of the available. So these are the main functions of spectrum decision. Then we have spectrum sharing, how to do spectrum access, how to allocate resources. So it basically deals with maintaining a certain quality of service by avoiding the collision of multiple cognitive radios, attempting to access the channel with coordination. So the main function of spectrum sharing are spectrum access, resource allocation, and channel selection. And finally, we have spectrum mobility, which is one of the most important parts of this framework. So basically, why I'm saying this is most important, because cognitive radios are generally visitors to the available spectrum band, and the cognitive radios need to switch from one channel to another available channel. Now this is known as, the switching of channels is known as spectrum mobility in CR network. So main function of spectrum mobility are spectrum handoff and connection management. So we'll be discussing this spectrum handoff in detail in the coming slide. So this slide is basically for understanding that SDR, that is software defined radio, is used, means you can say that cognitive radio is built upon software defined radio. So SDR is a basic platform on which to build a cognitive radio. It cannot automatically switch signals from one network to another, and hence human intervention is required. And the cognitive radio solves this problem. So instead of human intervention, intelligence is required. That comes in the form of cognitive radio. So the cognitive radio is SDR and intelligence. So nowadays there are many SDR platforms which are available from different companies. So there is a NI, board, USRC, Texas Instruments board, and so on. And there is one more which I have not written here, is WARP board by Mango Communication. And nowadays, recently this Agmatel Keysight has also come up with its SDR board. So there are many such boards available upon which this CR can be built. So now there are many issues in CR networks, including the spectrum management issues. So out of these different spectrum management issues, that is sensing, sharing, handoff, and switching, I will be discussing this third issue, that is handoff, because that is related to the mobility of the node. Then obviously there are security related issues because the nodes are switching from one channel to another channel randomly. So there is obviously security related issues. Regulatory challenges are there, that how to allow opportunistic use, then incentives for spectrum sharing, and finally building cognition to a radio, such as adding intelligence to SDR. So how to do it, how to come up with intelligent algorithms. And finally, cost is obviously an issue. So here I am going to discuss one issue, that is spectrum handoff, that is related with the fourth part of this spectrum management framework, that is spectrum mobility. So spectrum handoff in cognitive radio networks. So here in this figure, you can see, just 1 second. Yes. So here we can see that there are 3 channels in the frequency band. Here I am trying to explain what is actually spectrum handoff. So there are 3 channels, channel number 1, 2, and 3. So initially the cognitive radio is transmitting at channel number 1, for example. Okay. So here cognitive radio is transmitting at channel number 1, and when primary user 1 appears or it comes back, because the channel number 1 is primarily dedicated for primary user 1. It is a licensed channel for primary user 1, but the CR has started transmitting because PU was, you can say, in idle mode or in sleep mode. PU was not transmitting anything. So this channel was free. So the cognitive radio means the secondary user was transmitting on this channel number 1. But as soon as primary user 1 comes, in that case, the secondary or the cognitive radio has to stop its transmission. And it stops its transmission and looks for other available channel. And here it is shown that then it moves to channel number 2. And this movement from one channel to another channel, or the switching from one channel to another channel, is termed as spectrum handoff. Now same thing is shown below also, that now it has started transmitting at channel number 2, but as soon as primary user 2 comes back or it appears, then again it has to stop and then it has to switch to another channel. So the same story repeats again and again. So that is called as channel switching or spectrum handoff in cognitive radio network. Now, there are so many technical aspects of spectrum handoff in cognitive radio networks, and those technical aspects can be broadly divided into 4 parts. One is spectrum handoff information collection parameters. Second is spectrum handoff triggering, spectrum handoff constraints, and spectrum handoff performance parameters. So since the time is limited, I have been given just half an hour, and so it is very difficult to explain each of these parameters in detail. So I will explain some important parameters, and for the remaining I will give you the related paper, which is our own paper, through which if you go through that paper, so you can understand all these terminologies which is explained in very much detail detail in that paper. So I will give you the link of that paper at the end of this talk. So the first one is spectrum handoff information collection parameters. So these parameters basically deal with the information which is required for the spectrum handoff. And the parameters may be used either independently or in combination to perform the spectrum handoff. For example, the primary user arrival and other information. So the primary user arrival is the license band. In the license band necessitates vacating the channel, as I have shown here, that the primary user arrival necessitates vacating the channel for the secondary user, and hence it causes spectrum handoff in cognitive radio network. So primary user has high priority than cognitive radio to use the licensed spectrum band. So the CR needs to vacate the channel on the arrival of PU, and hence this is the most important parameter for the spectrum handoff occurrence in cognitive radio network. Similarly, there are some other parameters, for example, CR user mobility, signal quality, number of available channels, prioritized traffic, and so on. Then the second part is spectrum handoff triggering. So triggering is basically defined as the cause of spectrum handoff initiation. So there are many ways through which spectrum handoff triggering can take place: timing based, CR user mobility, spectrum sensing, and so on. So I'm just explaining the first one, the timing based spectrum handoff. So it basically considers the effect of decision timing for selecting the target channel in the spectrum handoff. So PU, primary user arrival rate, is considered for selecting the channel. So later on we will see that there are 4 types of handoff schemes which are based upon this timing based triggering, such as non-handoff, reactive, proactive, and hybrid scheme. So we will be coming to that. Then the third technical aspect is spectrum handoff constraints. So constraints basically deal with the restrictions for the spectrum handoff in cognitive radio networks. So these are the essential considerations for the spectrum handoff. So main constraints are application of single or multiple spectrum handoff, single user or multi-CR user, sensing related constraints such as on-demand sensing or proactive, the channel related constraints such as the use of licensed and unlicensed channel together, backup channel, and so on. There are so many parameters. And finally, the spectrum handoff performance parameters. So obviously these parameters, performance parameters, deal with the performance metrics for spectrum handoff. So there may be many performance metrics, for example, number of spectrum handoff latency, link maintenance probability of false alarm, spectrum handoff ratio, bandwidth utilization, and so on. So there are so many things which if you go through that paper, you will get a good idea of all these technical aspects. So this slide basically shows a broader classification of the spectrum handoff schemes which are available in cognitive radio networks. So here you can see we have divided it into some in many parts. So the first is the handoff triggering timing based spectrum handoff scheme. Then we have mobility based, then probability based, sensing based, operating mode based, game based, grade based, and there are some miscellaneous schemes also, including the fuzzy logic based, auction based, relay assisted, and so on. So this is a very wide classification of different schemes which are available in the literature. So because of the timing constraints, I will try to explain the first one, that is timing based spectrum handoff scheme, and for the rest you can follow that research article that I will provide in the end of at the end of this presentation. So, as I said, that the first one is timing-based spectrum handoff scheme. So basically, these are divided into 4 subcategories: non-handoff, reactive, proactive, and hybrid, which we can see from this figure. So the first figure is non-handoff. Figure A is representing non-handoff. Second is reactive. Third is proactive, and the fourth one is hybrid. Sorry. So in the non-handoff scheme, when the cognitive radio detects the arrival of primary user, it pauses its transmission. Here you can see. It pauses its transmission, remains idle in the channel, and waits till the current channel becomes free to use the current channel. Hence, the cognitive radio does not leave the channel. So in non-handoff scheme, the cognitive radio does not leave the channel and resumes its data transmission till high priority primary user leaves the channel, as shown here. Okay. So here the advantage is that there is very less primary user interference, but the waiting latency is very large and unpredictable also. Second is reactive. So in reactive, the target-free reactive is similar if you have heard about different reactive and proactive routing protocols. So idea is same, philosophy is same. So in reactive spectrum scheme, the target-free channel is sensed on demand and the handoff action is performed in reactive manner. So the sensing of the target-free channel and handoff action is performed after the handoff time-based triggering event, as shown here. The channel switching is done after identifying the free channel. So here in general, if we see, the reactive spectrum scheme has less handoff latency than waiting latency for non-handoff scheme. Then if we quickly come to the proactive part, so here the spectrum sensing for free channel and the handoff action are performed in proactive manner. The target free channel for future spectrum handoff is based on PU traffic. The cognitive radio is able to predict the primary user arrivals a priori, and hence the handoff latency is reduced to a great extent in contrast to or in comparison to reactive handoff. So, but the important thing is that the primary user's traffic model should be predicted in a very nice manner. So, if it is predicted wrongly, then it leads to a poor spectrum handoff. So, this prediction should be very good. So, if we compare it with reactive, so here it performs better than reactive in terms of handoff latency when the sensing time is large. And last one is hybrid. That is obviously the amalgamation of the reactive and the proactive schemes. So it combines the concept of both reactive and proactive. It uses the proactive spectrum sensing and reactive handoff action. So with the help of proactive sensing, the free channel is prepared in advance. And the advantage of proactive sensing is that target free channel is identified well before the handoff action. And hence it reduces the handoff latency compared to the reactive scheme. So briefly if we say, so it is a kind of compromise between the reactive and proactive, and the handoff latency in the hybrid scheme is less than the reactive and more than the proactive scheme. Okay. So this I tried to explain the first one, the timing based scheme. So similarly, we have more mobility based, probability based. So I am skipping this, mobility based and others. Then there is also a comparison of all these schemes based upon the different parameters. For example, the applied domain, the complexity of schemes, and so on. So this all can be found in the paper. So finally, I am coming to the last point, which is the last slide, which is the most important slide, I think, that gives an idea about the spectrum handoff research issues and challenges. So there are so many research issues and challenges that are still open, and one can start working in any of these areas. For example, the first one is intelligent spectrum handoff. So here the available spectrum handoff schemes for cognitive radio networks, it lacks, means the main difficulty is to develop a spectrum handoff scheme which is truly beneficial in a dynamic environment. Okay. So it is believed that wireless networking becomes increasingly pervasive and which need to learn network conditions with knowledge and coordination to work correctly and efficiently. And therefore, there is a need of a self-organizing intelligent spectrum handoff scheme which works correctly and efficiently for the cognitive radio technology. Then priority based scheme, which is also very important because it is sometimes it becomes very important to transmit some emergency messages. For example, in you can take an example of e-health where the condition of the patient has to be transmitted immediately. So in that case, there is a need to prioritize the traffic according to the emergency, and the channels should be allocated immediately. So we can come up with some priority based spectrum handoff schemes. Then interference avoidance is very, very important because the node is switching from one channel to another channel randomly. So the interference avoidance becomes very, very important. Then coordination based spectrum handoff. So in coordination based, here we can say that the existing work on spectrum handoff mainly focus on switching of signal from one frequency band to another available frequency band, regardless of the frequency gap between the current and the target channel. But there may be hardware limitation. The user can jump from current frequency band to other nearby depending on acceptable switching delay and other constraints. So there is limited work in this area which considers the impact of limited handoff agility, and hence this issue needs to be considered to avoid unnecessary, inaccurate and misleading spectrum handoff. So coordination is very, very important. Then number of spectrum handoff must be reduced because ultimately it is not a good thing to switching the channel, switching from one channel to another channel. So the number of unnecessary handoffs must be avoided. Obviously, there is a dynamic and broad range of spectrum availability. So the hardware limitations are there. So there must be one must consider this broad range of spectrum availability. Then if coming to this part, standardization of spectrum handoff schemes, which is very, very important because you have seen that currently in the literature there are more than 30 type of schemes which are available. So there is till now there is no standardization of spectrum handoff schemes for uniform adoption of handoff. So it must be developed in such a manner that permits its end users and service providers to easily grasp the existing and upcoming internet and network scenarios. So standardization of handoff is very, very important. Then improving the connectivity and optimizing handoff. So connectivity between the nodes is one of the important issues. The use of backup channels and cooperation among the nodes may improve the connectivity. The spectrum handoff schemes must be developed in such manners that improve the connectivity. So these type of handoff schemes will be very useful for cognitive radio ad hoc networks. So if we talk about ad hoc networks, the connectivity is a big issue. So in that case, it becomes very, very important to consider the connectivity. And finally, we have optimizing the handoff collection, information collection parameters. So basically, the idea is that it becomes very difficult to consider the impact of all the collection parameters for a spectrum handoff because there are so many parameters. And the major disadvantage we can say are increase in the complexity and increased spectrum handoff delay. And hence, there is a need to optimize the spectrum handoff information collection parameters for efficient handoff. For example, if we take the example in case of ad hoc networks, the velocity of the moving primary user and cognitive radio user are maybe major handoff information collection parameters, which should have given high weightage than other parameters. So optimization of information collection parameters is also very important. So these are some of the important research issues and challenges in the area of spectrum handoff in cognitive radio networks. Now, this is the paper which I was talking about. This is our paper, Spectrum Handoff in Cognitive Radio Network, a classification and comprehensive survey. So if you go through this paper, so whatever I have covered, whatever I have left, you can find everything available in this paper, and that gives you a very good idea about the cognitive radio networks in general, and with specifications of spectrum handoff in cognitive radio networks in particular. So that is all from my side. Thank you so much for your patience, for listening me, and thank you to the organizers for giving me this opportunity to present this talk before you. So thank you. That is all from my side.
Thank you, sir. Sir, I believe there are a few questions. The first one is by Mr. Devabrata Singh. Mr. Devabrata Singh wants to know what is the difference between handoff and handover techniques?
No, actually there is no difference. Both the terms are used interchangeably. So actually there is no difference between handoff and handover. Both are same.
Okay, thank you, sir.
I will also like to add one more thing, that in cognitive radio networks, the channel switching is also the same thing. So we call it as channel switching or handover or handoff, all are same.
Okay. If the audience members have any more questions, they can post it in the chat box so that we can direct it to Arun sir.
You can post me, you can connect to my email ID, we can discuss it later also. I have no problem in any way.
Okay, sir, in that case, we will wrap up this Q&A session. Thank you, Dr. Arun Prakash, for this insightful session on cognitive radio networks. We are grateful to you for joining us today, sir. Thank you so much.
Thank you so much. Thank you.
Thank you, sir.
Good day to all of you.
Good day. Now, it's my great honor to invite Professor Dr. D.P. Kothari, an eminent educationist who has made immense contributions to the advancement of engineering education in India. Currently working as chairman of THDC Institute of Hydropower Engineering and Technology, Uttarakhand, Dr. Kothari has held leadership positions at various engineering institutions in India, including IIT Delhi, VNIT Nagpur, and VIT University Vellore. He is a recipient of multiple awards such as Eminent Engineering Personality Award from Institution of Engineers in 2001, National Award for Science and Technology from Uttar Pradesh Government in 2001, UGC National Swami Pranavananda Saraswati Award for 2005 on Education, Lifetime Achievement Award for Educational Planning and Administration by World Management Congress in 2009, and 9 Lifetime Achievement Awards by various agencies in years spanning from 2016 till 2018. He has published over 842 papers in national and international journals and conferences, and has authored and co-authored around 60 books, including power system optimization, electric machines, and power system engineering. His research interests include optimal hydrothermal scheduling, unit commitment, maintenance scheduling, energy conservation and power quality, and energy system planning and modeling. I would now request Dr. Kothari to address the audience on AI techniques and optimization. Over to you, sir.
Thank you very much for the nice introduction. Am I audible?
Yes, sir, you're audible.
Good. So first, let me thank Professor Soman to give me an opportunity to and all the organizers this afternoon now, I think, just about to be afternoon, for giving me to talk to you on optimization and artificial intelligence technique. So before I start, I hope there are students there, faculty there, and administrators there. So first 2 minutes I'll take for students. All students must get up at 4 a.m. That is the Brahma Muhurat. The mind is fresh. It is 100% efficient. Whatever you'll read, you will remember. Then 5 minutes yoga, 5 minutes prayer, and 10 minutes morning walk, and then start working. All students must read one English paper every day, and they should do a hardware project, and out of that, they should publish in the Student Journal of India. Then there are 2 websites, kindly note down, where you can do for summer internship. One is summer internship INSA Bangalore, another is summer internship IIM Gurgaon. 2 months they give you opportunity to work with any IIT, any NIT, and then they will give you a railway fare plus so many things. And in that 2 months you can see how that IIT, NIT works, how are their labs, their library, and you learn a lot. Then the student should do, the regular studies and attend all the lectures, especially since you are paying for it, and the jobs is a very important point nowadays. So please appear in GATE exam, appear in UPSC, IS, and engineering services. If you appear in GATE, you not only get admission in postgraduate, but also service in public sector units like Power Grid, NTPC, BHEL, and others. Now come to the faculty. Faculty have to do 5 things. Good teaching, I'm sure they're all doing. 1 paper minimum per year. Funded project. Kindly apply for funded project. Because nowadays, the teachers, the authorities ask you when you go for promotion, how much resource you have generated for the college. So you have to generate resources. 3rd thing, you should do consultancy. 4th is write a good book. See, if you write a good book, you will be remembered when you are gone. See, today Professor Nagarati is not there, his books are there. Professor C.L. Wadhwa is not there, his books are there. Similarly, Professor Gorakh Prasad's calculus, Loni's trigonometry, all those people are not there, but their books are there. So that's why I am requesting you to write a book. And anybody can take my help for writing a book, getting it published. My mail ID you can note down. Professor Soman will give you. My phone number you can take. You can ask me any question anytime. Just say Jajapur and I'll try to reply to you. Now we start. Now we are the authorities. I had to say 3 minutes, 3 points for authorities. Please see that your faculty don't leave you. With a good faculty, if he or she leaves, you won't be able to get it. So see that they are happy there in your college, in your institute, and give them the salary within first week of every month. There are some private colleges who don't pay salary properly. Even in Corona days, some are paying half salary, some are paying 1/4 salary, some are not paying at all. So you can well understand how can they pass these 5 months without money, where practically everybody is home arrest. So I hope you are all safe, you are all okay. And now another thing with the authorities should see that they should get promotion at regular intervals. See that they do whatever you want them to do and you give them promotion, give them increments, whatever is possible. Now we come to the lecture, that is optimization and artificial intelligence. Next slide, please. Slide number 2. Yeah. What is optimization? Optimization means either maximization or minimization or both, called min-max problems. Please understand, optimization came to the world because of Hitler. Don't think the dictators do everything bad. Hitler attacked Second World War, and then Dr. Winston Churchill was the chief prime minister at that time in UK. He called the meeting of all his scientists and engineers. He told them, we want to win this war with minimum effort, minimum casualty. Please start working on MOR, military operation research. So all scientists and engineers started working. Unfortunately, the war over was 45 because of the bombardment of Hiroshima and Nagasaki, but the technique also came in 1945 called linear programming by a fellow called Danzig. Linear programming is objective function linear, the constraints also linear, and the decision variables are non-negative, either positive or zero. The method used was simplex method. Then we came to dynamic programming, 1950. A fellow called R. Berman of USSR gave that technique. That is a multi-stage decision process can be solved by using dynamic programming. Then came in 1956, Pontryagin maximum principle. Pontryagin was also a Russian mathematician. So there is a continuous maximum principle and discrete maximum principle. Then in 1963 came nonlinear programming by a fellow called Carpentier from France. There in nonlinear programming can be solved by forming a Lagrangian, that is objective function plus minus lambda times the constraint. Lambda is a Lagrange variable. There are three Kohn-Tucker conditions. Kohn-Tucker were the two engineers who gave this method, presented in Chicago in 1953. In my book, I have given all the details about it. You can see them. Power System Engineering, 3rd edition, in 2019. There are 29 chapters. Please read each and every chapter. Very important. This is for electrical engineer. Other electrical engineer also, there is a power system optimization book. You can read that. And if you want to read pure optimization book, then there is a fellow called S.S. Rao. He was a mechanical engineer in IIT Kanpur. He wrote that book. Then he shifted to Purdue University. So it is a wonderful book. You can kindly read it. So after this, let me read this, what is written here. Optimization started in the world because of the, this is what I told you, Adolf Hitler. He third Second World War on the world in 1939. Sir Winston Churchill was then wartime prime minister. This I already talked. This was military operation research. Later word military was dropped and it became operation research. All management people also read operation research. Chemical engineers also read. It is interdisciplinary. In fact, these 5 subjects must be taught to everybody. Number 1, optimization. Number 2, reliability. Number 3, energy and environment. Number 4, material science. Number 5, waste management. Nothing is waste nowadays. Every waste can be used. So these 5 subjects must be taught. Especially if you are a university, there will be no difficulty in teaching them. Next slide, please. 3. Slide number 3. Can you change the slide? Who is changing the slide? Please change the slide number 3. Next slide.
Hello, Professor Shravan, are you there? Kindly change the slide.
Come. Okay. That's right. Thank you. Early classic optimization approaches. Fortunately, war, and this is what I told you, 1945 bomb. So the linear programming came. Then formal optimization on linear programming was started by Leonard Contuzian in 1939. The first well-known approach, the simplest method, was published in 1947 by George Danzig. And in the same year, the theory of duality was published by John von Neumann. And please understand, transportation problem, assignment problem, they are the extension of linear programming. Then there is a modified simplex method also. Any optimization problem has an objective function, set of constraints, and solution algorithm. Constraints are of 2 types, equality constraint and inequality. Inequalities are 2 types, hard inequality and soft inequality. For example, examination hours, 3 hours, they're hard. If you don't give the paper back, the invigilator will be very angry. He can write, take an extra time. Soft constraint is the voltage variation. Voltage, if it varies from plus minus 5% is the normal standard, but it becomes plus minus 6, nothing is going to happen. So it's a soft constraint. Constraints are either equality or inequality. Inequality are either hard or soft. Yes, slide number 4. There is an assignment problem, this I told you, transportation problem. There is a quadratic programming or geometric programming. These are also very important methods. Quadratic programming means the objective function is quadratic. In 1950, R. Bellman, this I told you, dynamic programming, used for solving multi-stage decision process, like aeroplane, hydrothermal scheduling, or unit commitment. All these 3 problems can be solved by dynamic programming. In my book, in chapter 7, I have given the unit commitment to be solved by dynamic programming. In 1950, R. Bellman gave dynamic programming used for solving multi-stage decision process. So many decisions we have to take in multi-stage, like marriage. First, as boy and girl meet, then their parents go and meet them, and so on. So multi-stage. In one stage, marriage cannot take place. Like aeroplane, hydrothermal scheduling unit command. Yes, slide number 5. Early classic optimization approaches. Formal optimization on linear programming was started by Leonard Cohen in 1939. The first well-known approach, the simplex method, was published 1947. This we have talked. And in the same year, theory of duality. Here, six number. This I told you. 56. Russian mathematician Pontagin gave Maxwell principle, continuous discrete. French engineer Carpentier gave gradient technique, nonlinear program, to solve nonlinear program. In fact, all problems in the world are nonlinear. Nothing is linear. Of course, nonlinear can be converted to linear programming, linear problem, and solve it. Cohn-Tucker is the name of two scientists who gave the conditions. That is called Cohn-Tucker conditions. Chance constrained or stochastic problems were also solved by gradient technique. There are chance constraints. For example, load. There is a load flow equation. Then there is a load is a random variable. Similarly, water inflow is a random variable. There are 3 random variables known to all of you. One is load. If load won't have been there won't have been any electrical engineering. Then there is a water inflow. How much water will come particular month? Nobody knows. Second is a customer. When customer will come to the shop, nobody knows. Shopkeeper is always ready to welcome a customer. Death is a certain event, but we don't know when it is going to come. So it is a random variable. So whenever there are random variables involved, the problem becomes chance constraint or stochastic problem or probabilistic problem. Best book in probability theory is by Papulis, McGraw-Hill. You can read that book. Search technique. For example, if there is a thief and he has run away, then the police party will go there and search in a single area search or multi-area search. That's called search techniques to find optimal values. Good books are available by Headley, 3 volumes, and our own S.S. Rao. I told you about S.S. Rao. My book is there on Poisson optimization, second PHI 2011, Prentice Hall of India. Today is the end of era of the artificial intelligence. Hence, next we will discuss about them. That is the main topic. Seventh slide. Yes, artificial intelligence. What is artificial intelligence? Not just studying intelligent systems, but building them. Psychological approach. An intelligent system is a model of human intelligence. Engineering approach. An intelligent system solves a sufficiently difficult problem in a generalizable way. 8th. Slide number 8. Yes, there are 30 slides. We have to do them within half an hour. So the applied areas of artificial intelligence, heuristic search. Next is computer vision. Third is adversarial search, games, game theory, meta game theory, fuzzy logic, very important. The Professor Jade gave this theory in 1964 and he died last year. Everybody knows what is fuzzy logic, especially in electrical engineering. We use it very often. Management also, natural language processing, NLP. Then there is a knowledge representation. There is a planning. Then there is a learning. Yes, next slide, please. 9th. AI technology is supporting decision making. Decision making use information technologies in decision making analysis of what if, what is analysis used in transaction, processing systems and management information systems. What if analysis used in decision support system. Decision support system are used everywhere. Next please, 10th. Applications of AI techniques. Can we make it slightly big, this one, or it will be this much only? Can font be increased?
Sir, this much only, sir.
That's much, this was only, anyway. So, very difficult to read here. energy field. Arco and Technico Oil Company application. Neural networks used to help principal pinpoint oil and gas deposits. This is a very important problem. Where is the oil and where is the gas deposits? That can be found out by using this technique, neural network. The neural network is very important. All doctors and medical people use it. Government, Internal Revenue Service, software used to read tax returns and spot fraud. So the income tax people use it quite often. Human services, Merce Country, California. Expert system used to decide if applicants should receive welfare benefits or not. In USA, they give welfare benefits. So that can be found out whether he or she deserves or not by using neural network. Telecommunication, a BT group, a heuristic search used for a scheduling application that provides work schedule for more than 20,000 engineers. Transportation, this is American Airlines, expert system used to schedule the routine maintenance of airplanes. See, without maintenance, you know what has happened to the Air India flight from Dubai to Kozhikode. Of course, that was the problem of the tabletop airport, but again, maintenance is a very big issue. If you don't maintain power plants, they won't work for a full year. So maintenance, even we need maintenance. We need to have morning walk, as I told you. We need to do yoga. Maintenance is 3 types. There is a schedule maintenance, plant maintenance, and breakdown maintenance. We should not go to breakdown. We should have a plant maintenance and schedule maintenance. How to do maintenance? Again, optimization techniques are used. Inventory forecasting, Hyundai Motors, neural networks and expert systems used to reduce delivery time by 20% and increase inventory turnover from 3 to 3.4. Inventory and forecasting, SCI system. Neural networks and expert systems are used to reduce on-hand inventory by 15%, resulting in $180 million in annual saving. See, if you have more inventory, you need more space, more storage. So that to minimize that, this is an important problem. This is for every industry. Every engineering college, we have to so many things. I have been a director IIT, vice chancellor VIT Vellore, and director NIT Nagpur. So I know how much inventory we have to have. Money is also important. You can't go on purchasing. Inventory forecasting, Renault Aluminum, neural networks and expert systems. These are the 2 very important AI techniques used to reduce forecasting errors by 2%, resulting in an inventory reduction of 1 million pounds. See how much important it is, how much money can be saved. Inventory forecasting, Unilever, neural network expert system used to reduce forecasting errors from 40% to 25%, resulting in a multi-million dollar saving. See how much money saving you can do if you use AI techniques. 11, sir. 11 slide. Yes, robotics is a very important topic. See, electrical engineers have to do 5 things today, very important. Electric vehicles, we are going to have electric vehicles soon. In fact, Delhi government is giving 1.5 lakh subsidy for a car, 50,000 subsidy for the scooty or a bike. And please request all the chief ministers, directly Modi ji, so that 8 o'clock he can come and say, Mitro, today onwards you can purchase electric car and you will save 1.5 lakh. So robotics is very important. Robot is serving in a restaurant also. Robot can perform operation in operation theater. So robot is very important. Robotics, you should have to see, we should have BTech in robotics, BTech in AI techniques. Already IIT Hyderabad has started BTech in AI techniques, BTech in cyber security. 3 securities are very important now: energy security, food security, and cyber security. 3 conservation is very important: energy conservation, water conservation, food conservation. Take that much food only in your plate which you want to eat. You can go for second iteration. No worries. But don't fill the full plate and waste later on. Robotics involve application of AI. Excel of performing simple repetitive tasks. So a human being gets tired, but the robot won't get tired. He can always give you a cup of tea 20 times. But the human being, if you ask, you will say, sir, I'm tired. I want to take rest. Free workers from tedious and hazardous job, then maybe job may be hazardous. You may get hurt, you may get burned. At that time, robot can do these jobs without getting hurt, without getting tired. Have limited mobility. That is one of the problem with the robot. But robot can have a multiple freedom, then mobility is no issue. Operation is controlled by a computer program that includes commands. So computer programming is very important. And please use these computer techniques to your field, like machine learning, IoT, cloud, deep data system. All these things one has to learn and apply in your own system, whatever is your branch. Operation is controlled by a computer program that includes commands, includes programming languages for controlling variable assembly language, VAL, to 12th number. Yeah. Expert system is very important. What is expert? You must have all got some interviews, then experts will be sitting there to know how much you know. Mimics human expertise in a field to solve a problem in a well-defined area. Used for activities that human experts have already handled successfully. Task in medicine, geology, education, and oil exploration. Oil is very important. Work with heuristic data, which encourages applying knowledge-based or experience to solve and describe a problem. See, expert systems are two types: knowledge-based and rule-based. For example, if it is raining, you know that you have knowledge it is raining. So go with an umbrella or a raincoat. Another is rule-based. Rule is monsoon days, you must carry umbrella, whether it is raining or not. So it may rain anytime. So that is how two types of expert systems are there: rule-based and knowledge-based. Both can be. There is one of my student, S.N. Saran, has written a very good book on expert system. You can read that. Yes, 13, please. Components of an expert system: knowledge acquisition facility. Software package has manual or automated methods for acquiring and incorporating new rules and facts so that expert system is capable of growth. Knowledge base, and similar to a database, but in addition to storing facts and figures, it keeps track of rules and explanations associated with facts. Includes factual, heuristic, meta types of knowledge. That is knowledge base. 14. Components of expert system: knowledge-based management system, KBMS, similar to a database management system, used to keep the knowledge base updated with changes to facts, figures, and rules. Use interface provides user-friendly access to the expert system. 15. Components of expert system: explanation facility, performs tasks similar to what a human expert does by explaining to end users how recommendations are derived. See, every expert has to give a recommendation. Like in your interviews, the expert will tell whether to select you as a professor or not. Normally they should, if you have done enough work, unless until there is some politics, and politics is everywhere. Interface engine, similar to the model-based component of a decision support system, uses techniques of forward and backward chaining to manipulate a series of rules. 16. Yes, this is the airline industry, forensic lab. Nowadays, Sushant thing going on, and forensic people are working overtime to find out what happened to him. Banking and finance. Banks are going to be merged now. So banking and finance is very important. Our GDP has gone down. So let us see how it will come back soon. Education, new education policy has come. Now everybody will get something, either a certificate or a diploma or a degree. Nobody will go empty-handed. That is the one part of the beauty in education, new education policy. But my only worry is that they are going to teach in the mother tongue, nothing wrong in it. But suppose you are in Karnataka, you have studied in Kannada, and suddenly your transfer happens in UP, then you have to again start in Hindi medium. So that is why one should learn more languages. If you know more languages, better it is. Food industry. Food industry is very important, and expert system can be used. Personnel management is also important. See, in an industry, in a factory, in a company, you have to manage people. How do you manage them? How to take work out of them? There again, the expert system can be used. Security. Security, I just told you 3 securities: food security, water security, and energy security, cyber security. Security, there is a power system security, full separate field is there. US government. So US government is doing a lot of work, and then they don't have their own educated people. That's why, see, if they withdraw Indian students and Indian professors from US, their education system will collapse. That is why they are hiring people, H1B visa, this visa, that visa. All agriculture. The India is an agricultural country. There are several courses we take. So how to do irrigation? That is, see, the solar water pump is very important. If you use it, no farmer will commit suicide. And then expert system can be used. You have to tell them when the forecast, when the rain is going to come, so that they are ready for that. So that's why expert system will help you. Advantages of expert system: never become distressed, forgetful, or tired. Duplicate and preserve the expertise of scarce experts. Preserve the expertise of retiring or relieving employees. Now in IT system, they have started giving 5 more years for a retired professor. Their faculty is a very good, very big problem nowadays. No good faculty is available. Even bad faculty is not available. Forget about good faculty. When I was the director, we used to get good faculty. Now the new director, Professor Rao, is telling me now bad faculty is not having. I don't know why people don't want to become a teacher. Teacher is a very noble profession, and with 7th pay commission, I feel it is enough money. Plus, I told them 3 ways to get more money: consultancy, book writing, and funding project. And go abroad for 1 year, even without pay leave. Work there and then come back. You can recharge your battery and come back. Everybody has to go abroad, the faculty members. Create consistency in decision making. Decision making, you have to be consistent. Suppose you have promoted one fellow with just PhD. Now another fellow with PhD you can't reject. Same institution, you can't have 2 sets of rules. Improve the decision making skills of non-experts. There are non-experts also. You have to make them experts. Next please, 18. Yes, this is what I was talking about. Professor Zade, Latif A. Zade, he died last year, and in 1965 he proposed the fuzzy set theory. Let me tell you the story how he did it. He invited 4 families for dinner, and naturally families means ladies will also be there. All the 4 ladies started quarreling. He says, I am prettier than you. I am more beautiful. Then Zade came and said, don't fight. I have a fuzzy theory. I'll tell you who is more beautiful. So that fuzziness means that it's not known with certainty what is happening. So that is how the fuzzy logic came in. And he satisfied all the 4 ladies. Half glass is full, half is empty. Fuzziness. Night, evening time and morning time, roughly same. The birds are there. The reddishness is there in the sky. So one never knows whether it is morning time or evening time. Fuzziness. So there are so many problems with fuzziness. We have to solve them, and we can solve with the fuzzy logic. It is flexible and conceptually easy to understand. Allows a smooth, gradual transition between human and computer vocabularies. Deals with variations in linguistic terms by using a degree of membership. The membership can be triangular, it can be hexagonal, and so on. Then defuzzification also takes place once you get the answer. Designed to help computers simulate vagueness and uncertainty in common situations. Works based on the degree of membership in a set. 20th. Next slide. Yes. Areas where fuzzy logic is used. Search engines, automobile and other vehicle subsystems. Used to control the speed of vehicles in anti-braking system. Temperature controllers, air conditioners. Now, we don't know when you are going to feel hot or cold. So that is fuzziness. So what temperature? You should, now I am having 28 degrees centigrade. So it depends on the person also, depends on the area, depends on the season, and so on. So that can be controlled by, similarly, washing machine. Which cloth is dirty, which part of the cloth is dirty. So you can put more soap there. That can be done by fuzzy logic. Camera for autofocus. Home appliances, rice cookers. The South Indian people take a lot of rice. Even Bengalis take. In Maharashtra also they take, shevatche bhat. I don't know how many of you know Marathi. I know 10 languages. That helps me in connecting with the people. So dishwashers I told you just now. 1 minute. washing machines and other. This I told you. Yes, 21st, 21. Artificial neural network. This is ANN is very important topic. Computational models that try to emulate the structure of the human brain. Wishing to, the human brain contains of neurons, and that is how the ANN has come. Wishing to reproduce at least some of its flexibility and power. ANN consists of many simple computing elements, usually simple nonlinear summing operations, highly connected by links of varying length. Yes, 22nd. Networks that learn and are capable of performing tasks that are difficult with conventional computers. Playing chess, the Anand can play chess with the computer. Human computer can win also sometimes because of this ANN techniques. Recognizing patterns in faces and objects. Face reading. See the railway, those TT, they can find out from the face reading who is carrying ticket and who is not carrying. There will be no time to check everybody, especially in cities like Bombay, Kolkata, Madras, and Delhi. So many people come at the same time, and so many trains come at the same time. So that's why this technique helps them in finding out who is having ticket and who is not having ticket. Use patterns instead of if, then, else rules used by the expert system. Create a model based on input and output. 23rd. This is the structure of a typical neuron. There is a dendrite, there is a nucleus, cell body, node of Renwier, axon, and myelin sheath, then Schwann cell, and axon terminal. Please understand, this is a century of biology. That's how the ANN is important. Biomedical, biochemical, biomass, and last century was century of physics. Now, even IIT Delhi has opened a full-fledged department of biology. You could have never imagined when IITs were formed that IITs will be having a biology department. Normally, biology means medical and mathematics means engineering. That has been the thinking since long. But now it is not like that. Next plus 24. Yes, tasks involving the use of ANNs. Bankruptcy prediction, especially those who deal in the share market. My request to all of you is no share market, no mutual fund, only FDR, fixed deposit, or RD, recurring deposit. Money is safe. In share market, nothing can be predicted. So kindly don't go for share market. This is my personal request. So bankruptcy prediction can be done by this ANN. Credit rating, Moody's credit rating and so on. They use this ANN to predict. Investment analysis, how to invest, where to invest, what to invest, how much to invest, can be used by ANN. Oil and gas exploration. We have been talking about oil and gas exploration because energy, bin pani sab soon. No energy, no progress. Target marketing. Today we are having 3.71 gigawatt of installed capacity. To become a developed country, we need at least 5 gigawatt. And that's why now electrical engineers is become very important for jobs. But we need all people in energy. We need mechanical, we need civil, we need chemical, we need computer, we need management people, physics, chemistry, everybody. That's why the oil and gas exploration is very target marketing. So we have to market, we have to see marketing. For example, brand, all those things also can be done ANN. 25. Yes. Particle swan optimization, PSO. That's a very important technique nowadays used especially in power systems. A particle swan optimization process proposed by Dr. Eberhard and Dr. Kennedy in 1995, not much old, just 25-year-old, is solely based on a population stochastic optimization technique. Stochastic, I explained you, we need stochastic optimization everywhere. This method was designed by the researchers after inspired by social behavior of flocking bird and schooling fishes. So fishes, you can see the behavior of fishes and birds, and this method was formed. This method shares numerous resemblances with the evolutionary computation procedures, such as genetic algorithm, GA. That's a very important topic. PSO algorithm is widely used in various research fields like ranging from artificial neural network training to other areas where GA can be used in the system, genetic algorithm. 26. Yeah, swan intelligence is a branch of artificial intelligence where we observe nature and try to learn how different biological phenomena can be imitated, in a computer system to optimize the scheduling algorithms. In swarm intelligence, we focus on the collective behavior of simple organisms and their interaction with the environment. Please understand, the AI technique started in 1950 and still developing. It's not that we have stopped. The development never stops. It goes on. So there is this is about 70 years or over since the artificial intelligence started, and it will still continue. There are two types of optimization algorithm in swarm intelligence. The first one is ant colony optimization. Here the algorithm is based on the collective behavior of ants in their colony. See, after all, you must have all observed how the ants, that is cheetah, is going. Suppose there is a food article. They follow that food article. In between, water comes. That is a constraint. They avoid water and go to the food article. That is called ant colony optimization. That is how they got the inspiration to create this method. I hope all of you know that story of the Makkad Jali, a king who got defeated 6 times. Then we saw the Makkad Jali, the Makkadi is making Jala again and again. So he said, why not? I try 7th time, and then he won. The first one is the ant colony. Here the algorithm is based on collective behavior of ants in a colony. The second technique is a particle swarm optimization, PSO, which we are just talking. 27. In PSO, the focus is on a group of birds. This group of birds is referred to as a swarm. Let us try to understand the particle swarm optimization from the following scenario. Example, suppose there is a swarm, a group of birds. Now all the birds are hungry and all searching for food. These hungry birds can be correlated with the task in a computational system, which are hungry for resources. Now in the locality of these birds, there is only one load food particle. This food particle can be correlated with a resource. As we know, tasks are many, resources are limited. So this has become a similar condition as in a certain computational environment. Now the birds don't know where the food particle is hidden or located. In such a scenario, how the algorithm to find the food particle should be designed. If every bird will try to find the food on its own, it may cause havoc and may consume a large amount of time. Thus, on careful observation of this swarm, it was realized that though the birds don't know where the food particle is located, then they do know the distance from it. Thus, the best approach to finding that food particle is to follow the birds which are nearest to the food particle. This behavior of birds is simulated in the computational environment, and the algorithm so designed is termed as particle swarm optimization algorithm. 28. Tabu. This tabu is not an actress tabu. This is a different tabu. Tabu search method. Tabu search created by Fred W. Glover in 1986 and formalized in 1989 is a meta-heuristic search method employing local search methods used for mathematical optimization. There is a local search and there is a universal search. Tabu search enhances the performance of a local search by relaxing its basic rule. First, at each step, worsening moves can be accepted if no improving move is available, like when the search is stuck at a strict local minimum. We are not interested in local minimum. Normally, we want universal global maxima or minima. Introduced to discourage the search from coming back to previously visited solutions. So there should not be oscillations, there should be convergence and final convergence. The implementation of tabu search uses memory structures that describe the visited solutions or user-provided sets of rules. If a potential solution has been previously visited within a certain short-term period, or if it has violated a rule, it is marked as a taboo, forbidden, so that the algorithm does not consider that possibility repeatedly. So we should not get oscillations. Yes, 29. Natural language processing, NLP. NLP also means nonlinear programming, but it is not here. Here it is natural language processing. Developed so that users can communicate with the computers in human language. provides question and answer setting that's natural and easier for people to use. Useful with the databases. Used for call routing, that is in computer people, stock and bond trading. Then the banking by phone. Phone banking is very important nowadays. 30. Categories in NLP system. Interference with the databases, machine transition, text scanning and intelligent indexing programs for summarizing large amounts of text, generating text for automated production of standard documents, speech systems for voice interaction with computers. 31. Activities performed by NLP system, interfacing, accepting human language as input, carrying out the corresponding command, generating the necessary output, knowledge acquisition, using the computer to read large amounts of text and understand the information, summarize the important points and store information so that the system can respond to inquiries about the content. 32. Integrating AI techniques into decision support systems. AI techniques help improve the quality of decision support systems. Adds explanation capabilities by integrating expert systems and learning capabilities by integrating ANNs. Creates an interface that is easier to use by integrating on an NLP system. Systems are called integrated DSSs. 33. Conclusion. Artificial intelligence technologies apply computers to areas that require knowledge, perception, reasoning, understanding, and cognitive abilities. Intelligent agents are becoming more popular, especially in e-commerce. Nowadays, everything E is very important. E-business, e-commerce, especially in management system, MBA, you do a lot of e-commerce. Now, everybody is doing e-commerce now. Fuzzy logic is designed to help computers simulate vagueness and uncertainty in common situations. Size and complexity of the human language has made developing NLP systems difficult. Is there any 34? Just see. Yes, that is. Thank you, ladies and gentlemen, for patient hearing. So if there is any questions, I'll be very happy to answer. Any questions, please?
Audience members can post their questions here so that Dr. Kothari can answer. The participants here are requested to post their questions in the chat box.
You can ask any other question besides this topic also, about the future jobs and the postdoc and the internship. I told you the 2 websites for internship. I hope they have noted it down. They can work in summer months in any IIT, any NIT, any IIM, any good institution. About project, PhD, about book writing, anything you can ask. If you are not wanting, then you can always, I have given my mail ID to a number to them, all participants.
That would be great, sir. I think
you can do that. Professor Soman knows about it, so that I can help them whenever they want. They can use my as a referee also, because you need references. Anybody who is doing PhD, I can examine PhD in any topic. You can always give my name as the examiner. I give report in 7 days, 8-day viva, so that you don't miss your putting doctor in front of your name.
I think, sir, we can wrap up the session here.
Okay. Now, my request to all faculty who are not PhD to do PhD. Modi ji can always say 8 p.m. to tomorrow onwards, no PhD, no job. So in order that should not happen, kindly do PhD. Those who are not done. Those who are done, please start guiding your friends, your faculty members in your college, in your institute, so that they also become PhD.
So yes, I think there's one question by Ms. Pallavi Thare. Can we make any rule-based system for engineering institute? Any example and how to process such a system?
Sure. See, for example, there are 22 IITs, 33 NITs, 4 BITS Pilani, 4 VIT Vellore, 4 SRM, 4 Manipal, 5 Geetam. So whichever is your institute, you can also make it IIT, not because of the nameplate, but whatever IIT does, you also do. Same culture, same rules. Then, you can also become an IIT. Government cannot make every institution IIT or IIM, but you can make yourself. So the rule is you have to visit that, as I told you, summer internship. The senior people can make a committee and go to any IIT, any NIT, any IIM and see what they're doing. In fact, all are available on the websites also. In fact, you may be having a faculty member who got PhD from an IIT. He or she can also help you. So these are the simple rules. For example, the students' good admissions should be good. And then, and for my God's sake, don't read cheaper books. Suppose somebody is in MP, there is a Shivani there. Don't read Shivani. Kunji bolte hain Hindi mein usko. Read good books, whether foreign books or Indian books. It doesn't matter. But don't read Kunji and cheaper guides. That is a short-term gain you may have, but long-term you'll no gain. And similarly, project, as far as possible, do hardware project. After all, engineering, there's a hardware. And practice school, everybody should have. Like every medical college is associated with the hospital, so every engineering college must be associated with the industry. Follow BITS-Pilani model, have a practice school in your college. That means 6 months in industry, 1 semester with a faculty supervision. And faculty who goes there may be given suitably more money because he is sacrificing his family, his children. He's going with. I went there to Nagda along with a badge. That badge always remembers me. Valerian. So that is what my request to, if there are engineering sitting there, faculty members or principal, directors or vice chancellor, kindly follow the practice school. Practice school is for everybody. Arts college, commerce college, or just follow BITS-Pilani model. We go to you
So
can
those are
see
great
the
answers, sir.
website of BITS-Pilani and follow that. Yes, ma'am.
Yes, sir. So these are very great pointers for any engineering institution, sir.
Yes,
So I
and
think
if you need me,
with your permission,
after the lockdown is lifted, I can come to your college or institute and do mock interviews for teachers as well as students. How much teachers have done and what next? I have 76. I have complete. I mean, my age is completed 50 years of my teaching, research, and administration. I have been perhaps the only fellow who has been IT director, NIT director, and a vice chancellor. So my rich experience I want to give, because you don't know when I have to go up. That date uncertain. I told you 3 random variables. That is the load, customer, and the death. Anytime death can come, and corona, no one never knows.
thank you, sir.
You
Sir,
can
look
use
forward
me
to your
whenever you
presence
want.
here, sir.
Yes.
Sure, sir. We look forward to your presence in our college.
Sure,
Sir.
sure.
Thank you, sir, for an extremely informative presentation.
No,
and I'm sure
my
the
pleasure.
participants.
And I'm thankful to
have
all of
taken-
you for giving me this opportunity.
Thank you, sir. Thank you so much.
All the best.
Thank you, sir.
Good day.
Now, please join me in welcoming Mr. Ankit Saran, Managing Director for Consulting in AI Data Analytics for Deloitte. Mr. Saran has over 20 years of global consulting experience in building data analytics and technology-enabled businesses. He has been shaping and driving enterprise agendas via large technology-enabled transformation for 50 plus Fortune 500 clients across industries. A thought leader and subject matter expert in artificial intelligence for digital, data analytics, and cloud space, he has served multiple leadership roles over the years to incubate, manage, and scale global business to drive outcomes. I would request Mr. Saran to deliver his speech on ambient intelligence, myth or reality. Are we ready for hyperscaling? Sir, please, over to you.
Thank you, ma'am. Can you all hear me?
Yes, sir, we can hear you.
Okay, thank you for the good introduction. Good afternoon, everyone. I know I am between you and your lunch. We are running a few minutes late here, but I'll try to keep this as short, sweet, and interactive as possible. So I don't use slides. I am a not big proponent of slides. I'm a person who would love to be talking to you in person, but given this pandemic and this new world we are living in, we are all evolving. So very happy to be here. Thanks for the Institute for arranging this. I think there are very few institutes who are taking this advantage of remote working, and this is one of the great institutes which I think has done a fantastic job by creating this agenda. And I was listening to Dr. D.P. Kothari just now, and I'm sure you must have had very intellectual and influential keynote speakers earlier as well. Having said that, let me quickly talk about myself and then talk about ambient intelligence and what it means to you. I don't want to make it more of an educational discussion. I will try to keep it what it means to you. So let me just talk about myself, right? So I'm not using slides. If you want to look at me speaking, so you'll have to pin me so that you can look at me, right? Okay. So overall, I have 20 plus years of consulting experience. Before my job, I'll tell you about a little bit myself, right? I grew up all over India. My dad was in the Air Force, so I'm a Fauji kid, and I'm an extremely proud Indian. After my rounds of changing schools across India, growing up in the Air Force environment, I did my engineering from REC Surathkal, which is called NIT Surathkal, post which I worked for 3 years with a bunch of startups, and I ended up with Cognizant in Hyderabad. Then I moved to the US, did my MBA, and then I worked in a couple of startup ecosystems for a year. And then I joined Deloitte 14 years back, and then we kind of fell in love with each other, and the love story has been going on for 14 years. About 8 years back, I moved back to India because India has always been my passion. And when I moved back to India, I was in Mumbai. Now I'm based out of Bangalore. And these 20 years has been predominantly driving technology transformations using data and analytics across different industries, right? I've served in financial services across I used to live in the Bay Area in the US. So I've done a lot of work with any cool technology firm you talk about, right? I mean, whether it's gaming companies, telecommunication companies, media companies, your virtual imaging companies, the multiple companies have driven multiple transformations for them. Last 8 years, I've been focusing on banking and insurance companies, as well as life sciences, specifically in the pharmaceutical and healthcare area as well. Okay, so having said that, right? I was listening to Dr. D.P. Kothari. I think he touched on very important and interesting areas, which reminded me of my college days, and I started thinking about some of my professors as well. It's extremely important, right? I don't think India has leveraged the universities and institutes in their technology innovation extensively. That mechanism very well exists in the West, right? But India is changing. And all of us in the corporate are changing, and we are working extremely hard to drive the change. In fact, many big companies have now ecosystems where they're working with universities to drive their agendas, their education agendas, the cross-collaboration agendas in terms of innovation, working on different projects, etc. So I'm pretty excited about that, and I'm pretty excited about what role India has to play in the coming years. One of the realizations which most people don't realize, which I had when I came back from the US, is the adoption of technology is at a much higher pace in India than any other country in the world. I've worked across geographies in the US, in Europe, in Australia, in Japan. I've worked with clients across, right? But the rate at which Indians are adopting technology is much faster. So the opportunity which lies in front of all of us is extremely huge. We haven't even scratched 1% of it, right? I mean, so I think that's a great area. Now, let's get to ambient intelligence, right? So what is ambient intelligence? Right. And you can ask questions, right? I mean, if you have questions, like if you Google ambient intelligence, you'll find good speeches, good scholarly articles. And is it something new? Right? So ambient intelligence, in my mind, is your AI ecosystem along with your hardware and software put in steroids. That means it's ready to scale. And this concept is not new. Like AI was never new. It has always been there 60 years back. There are research papers, if you point back, AI has always been there. Yes, it has become democratized today. The corporates are talking about it today. The industries are talking about how to leverage these technologies. But there are certain industries which have always led in the forefront, like defense services. NASA has been using AI technologies forever. I'll give you an example. So back, this is around 14, 15 years back, before I joined Deloitte. In the US, I joined a company called Trapeze Intelligent Transportation Systems. Okay, and it was a startup in those times, but we were the IoT of those days. We hired a bunch of engineers from NASA and Rockwell Collins and set up the shop in the Midwest of US, where we were creating a user experience for people taking public transit systems, right? We used sensors on buses. We had automatic passenger controllers. We used to plug in a device into every public transit system, extract all the information, send it via the network to the dispatch systems, have intelligent routing, have predictive maintenance, etc. But was it at scale? Was the technology at that time at scale? No. Every 3 months, we were in the business of changing the hardware, software, interfaces. I mean, it was not at scale. Today, it is at scale. The technologies have evolved, significantly evolved. It's much easier. But the understanding of how to make an AI ecosystem work is not evolved. Many of them still just believe in writing articles about that this is possible. How many of them have actually implemented it? Very few. I'll give an example. I think Elon Musk has got it, right? He has got it. He's working in the right way. There's a hardware, software ecosystem which needs to work together. When I talk about AI in steroids, it's about putting your hardware as well as software ecosystem on steroids. When I talk about hardware, right, it is about the edge devices. It's about edge computing. It's about embedded systems. It's about the networks that needs to support AI. When I talk about software, it's about data, analytics, cloud, right? Fog computing. There are multiple architectures. How do you test scale implementations? Do we have ecosystem players who can do that? So these are the technology and functional parts of it. Then comes the business angle. Which of this is feasible? Who's going to pay for it? What's the ROI? As an end user customer, are you going to spend those extra rupees, dollars, yen to actually for the services to get your comfort, or are you going to look for the cheapest device available? So there are multiple factors in play which one needs to think about when you talk about ambient intelligence, right? Now, if you read about ambient intelligence, there are articles about, well, this is in the next 10 years, this will drive the fourth industrial revolution. And I think there is a lot of truth to that. Every client I talk to today is talking about automation. It's talking about data. It's talking about analytics, machine learning, etc. Right? And some of them for the brand, for the sake of getting a brand permission in the marketplace. Some to actually increase their top line. That means increase their revenues, increase their customer base, etc. Right? And the others are looking at using those technologies to improve their supply chain, or basically improve their bottom line, increase their margins to make more money, get more out of less. That's the fundamental of every business, right? Then, if you put a circle around it, one needs to think about it is, what is the right thing to do? Is there invasion of privacy? What is ethical AI? What is ethical ambient intelligence? So there are a lot of factors which go into thinking about ambient intelligence. You can develop any technology in the lab, but can you scale it outside is the key. And to scale it outside, you need industrial use cases. And that's why I actually messaged the university that I think it's extremely important, not only for the computer science or electronics or IT faculty and students to attend these sessions, but it's extremely important for all faculty members of the institute and students to attend this. I did my civil electrical engineering long back. I am working with doctors, like Dr. Kothari said earlier. I am working with chemical engineers. I am working with electronics engineers, metallurgical engineers, mining engineers in different industries to solve business problems. And when you talk about an ecosystem where hardware and software are using each other's intelligence to make lives better, you cannot just be coding and making lives easy. All these fundamental engineering branches are becoming more and more critical to the success of every organization's future, be it networking. So electronic engineers, most of the times in my times, have become software engineers. Very few of them stuck to their core. Today, they are in demand. Some of my friends did their PhD in mathematics after doing engineering. They are in extreme demand. Some of my friends went into medical after 10 years of working in engineering because it did not engineering or software, just coding did not drive their passion. So go after your passion, understand the business around you, and then use technology to solve these problems. Technology will only become easier to use over the years. But the fundamentals of every subject is not going to change. And if you understand that well, you'll be extremely successful. Okay, so I'll leave it to you to decide whether ambient intelligence is a myth or a reality. And we'll talk about hyperscaling in a bit. So I think Dr. Kuthai talked about a lot of use cases, and I'm going to touch upon a few of them, right? And the way I look at things is very similar, but I'll try to make it more realistic based on my experience talking to different clients, right? So what works in the United States of America may or may not work in India. What works in Japan may or may not work in Australia. So it's extremely important to understand the local and the regional context when you're trying to find a use case to solve for. As students and faculty members in the university, I think in the corporate world, we can really leverage your thought process, your innovation, your minds are fresh, as opposed to many in the corporate world they get used to a certain idea, but when they get new ideas, that's when they thrive. Every year, I look forward to students from the campus. And by the way, I've led the campus program for Deloitte, and where we grew it from hiring 800 people to 3,000 people across India, right? And every year, I look forward to interacting with them because they are the smartest, they are the fresh blood, they have the most energy and the newest thought process. And I'm not looking for people who will say yes. We're looking for a thought process. And I'm a big proponent of hiring people across branches because diversity is the single most factor in my mind for a success of any organization. You need diversity of thought process. It is not about age, gender, anything. It's a thought process, right? Okay. Now, if you look at, and I strongly believe in the next 10 years, India, Southeast Asia, Japan, Singapore, China, they are the ones which will drive the sensor-led world, the intelligent world of software and hardware. Why? The debt or the technology debt is extremely low. Now, what do I mean by that? So the West, Europe and US has already invested a lot of money in technology over the years. Now they're innovating a lot. Now, if they want to move to the newer set of technologies where they want to use the AI and ML technologies within the sensors, edge devices, use fog computing, distributed computing on the cloud to actually change the way people live, they have to undo a lot of things and install new things. But the ecosystems of Africa, Asia, India included, has not yet got there. So it's a clean field, it's a green field, and it is a huge opportunity to drive transformation. And there are enough business problems in our world around. We talk about smart cities, we talk about smart homes, we talk about smart living, smart health, right? I mean, you cannot achieve that without a combination of hardware and software, intelligent hardware and software. It is always, see, intelligent sensors have always been there. Have they been intelligent? Maybe, maybe not. Maybe intelligent certain very specific industries. Can they improve? Absolutely. Do they understand the human context? In some ways, today's technologies enable that. Can they change or evolve based on human context? Yes. But are the technologies already there? Maybe, maybe not. They're getting there. If you look at all the rounds of startup funding today, everything is based around a sensor-led intelligent data software or hardware company in any industry. Okay, so we talked about a couple of things. We talked about regions, we talked about technologies, we talked about some use cases. Let me talk about some of the industries, right? So I focus a lot on banking and insurance as well in the last couple of years. Now, banking has already been using a lot of software-driven AI ML technologies. What has they been integrated with the hardware components? No. Okay. Is there a thought process about getting variables into the banking domain? Yes. Insurance? Absolutely. If you take the West, almost every automobile insurer, right? They have a device embedded in the cars to track how the driver is driving. And that driving pattern actually induces what your insurance premium is going to be. So there's a movement towards that. In India, we have not got there yet for many reasons, right? But it's an example of how you start changing or thinking about things. And by the way, the insurance companies did not invent that. These things have been discovered, experimented in the universities, in the campuses by students. It all starts small scale. It all starts with an idea. It all starts with the idea of experimenting. So think about that, right? Life sciences and healthcare, right? That's, I think, a huge area. But don't get misguided by looking at videos of what works in the West is going to work in India or Asia Pac. India is a country of a very different population and scale compared to Europe. If you look at a lot of internet videos, they'll talk about smart healthcare, smart living, having intelligent devices for older people because they have less people in those countries to serve them. You can use that in India, but someone is going to pay, much less rupees and dollars to hire a local help for you. But there could be a combination. Think about use cases which are relevant in front of you. Extremely important. Smart healthcare is an area which is untapped in the Indian marketplace. I'm personally working with a lot of startups to tap that marketplace. So think about it. Pharmaceutical development, right? I mean, that is one industry which is actually in the forefront of using data sharing, analytics, wearables, etc., to actually do drug development. There's only one reason if there's a vaccine which is for COVID is going to come out faster, because they have enough data about users. They have invested a lot in the last 10 years in these systems, and today they are able to use those results with their drug discoverers and drug testers to come up with a vaccine. Let's all hope it comes as soon as possible. Right? Similarly, there are a lot of examples in many industries. I can continue, right? I mean, I have a huge list here, but I know that I'm giving you and your lunch. I will just talk about hyperscaling quickly. Okay. So there are a couple of things about. So what is hyperscaling, right? So again, it's an industry buzzword. It's a gizmo. You can use it. It sounds cool. It sounds fancy, right? But let's talk about what's scaling. So you can come up with a very cool idea in the lab, and intelligent transportation system. That idea was in a lab in NASA, right? That same idea we took it to the market in the public transit systems. There are a lot of things which happens in the lab in universities can be taken to the market, right? But to scale anything, you need to have a software which is scalable. Something which works with one user or 5 users is very different than making it work for 500,000 users, 1 million customers, 5 million customers, 50 million customers. It's very different, right? How do you design the architecture around it? Both physical, software, what's the technology architecture? What's the, where will you host it? How much infrastructure is going to use? What is multi-tenancy? How are you going to segregate data which you collect? Are there local data regulations? So think about those angles as well when you have a use case and you want to scale it, right? Now, when you talk about scaling, it's also about testing. Testing a software is very different than testing a software hardware device combined. And it is not rocket science. It's about a thought process. It's about common sense. It's about thinking out of the box, right? When you talk about hyperscaling, right, one has to think about usability. One has to think about technology feasibility. There are a lot of technologies which have already evolved to help you get there. But there are a lot of limitations as well. Those are also areas for you to have your own startups. People who believe in ethics, there's a huge area around ethical AI, ethical ambient intelligence, artificial intelligence, that is all about inducing trust and confidence to use a certain system in the right way. Again, right can be defined by different people in different ways, but I think the fundamentals of ethics cannot be changed, right? So that's again an area which impacts the social and economic impacts. I mean, these are important. One other thing which I think is extremely important is standardization. So today there's no company which provides all the software and hardware combined in an ecosystem so that works with each other. So standardization and interoperability is extremely important. Now, how the architectures work across, be it network, physical, how the sensors actually react, Okay, what if the sensors you installed failed? What will the backup system look like? How can I replace the sensors? How expensive are these to replace the sensors? So there are a lot of considerations when you actually build something, right? You cannot understand these, even in the corporate world, right? I mean, I will say that there is a lack of understanding of what it takes to implement these technologies. Even in the corporate world, you only learn when you do it. So what Dr. T.P. Kothari earlier said, have labs, have ecosystem in universities, okay, to actually experiment. It's okay to fail. You will fail. It's only when you fail, you learn. And I'm talking from personal experience in corporates. Okay, so have that confidence, fail, and then succeed. Once you fail, you learn the arts of failure and how to succeed and how to beat them. There's no better learning beyond that, right? The ROI part is the last part. I mean, it's important to understand once you get into a habit of inventing, experimenting with sensors, making them intelligent, using technologies around out there. Every month, AWS is coming out with new technologies. I have friends who work in AWS labs in the US and India to create those technologies, right? So technologies will only become easier to use. But the use cases has to be driven from mining, metallurgy, mechanical engineering, retailers, e-tailers, telecommunication companies, automotive companies, every industry out there around you, which is actually producing material, okay? There's a technology set behind it, which is driving it. So learn about it. Use cases are right in front of you. It is not in research papers. Research papers can give you guidance. But you have to look around you of what can be made more intelligent so that someone's life will become easier. I'll tell you, one of my analysts who came from a campus 3 years back, he pinged me the other day, hey, Ankit, I just wrote a chatbot, which is gonna, my mother keeps running up and down, picking up clothes when it rains. So he written a chatbot so that his mother gets a WhatsApp message. The moment her mother gets a WhatsApp message, the moment it starts raining outside, or clouds start coming out. His first step was not using sensors. He was using crowdsourcing data. What's the next step? The next step is he's going to order some sensors and start using that sensor data to drive that information. But again, I love that idea for his innovation, for his thought process, and ability to drive it. Okay? Okay. So there are a lot of these areas which are important when you talk about hyperscaling. Okay. And last thing, before I would like to close, here are my 2 steps of advice for all of you, right? So be passionate about the topic you want to work in life about, right? You may or may not know it. Whatever you're working on, be extremely passionate about it. Learn about it, experiment with it. University is the best place to make friends with your professors, with your administrators, with your students. These friends will stay with you for life. The 400 students who work with me, just 1 second, guys, hold on. Sorry, guys, I have kids at home and they're working from home. So apologies for the background noise. So the last thing which I would say is extremely important to be passionate about the technology you work on, the industry use case you work on, believe in it. Leverage people's strengths, democratize data, don't hoard information. The more you hoard information, the more you're limiting your success. The more you talk to people, the more you share information, the more you learn from them. There's enough for everyone to be successful. You are the future of this country, the region, and the world. Thank you for your time. With that, I will close this. And if there are any questions, I'll be happy to answer them. Otherwise, feel free to go for your lunch. Thank you. Are there any questions?
Thank you. Yes, sir. There's one question actually. It's an early question from me. Isn't the technology adoption pace in India hindered by its slow network connectivity rate and varied demographics?
So you'd be surprised. India has the cheapest network availability around the world. right? We might think it's a slow, but there are countries around the world that are extremely slower as well. I don't think that India has adopted all the ways of collecting data without network connectivity as well. I'll give you an example of a company which is a seed company. Now, it works in the farms and fields, but it does not.
It works in the farms.
Hi, guys.
Hi, guys.
Just 1 second.
I think that was a great example of video bombing, and it's the new reality of working from home. We will wait for some time for Mr. Saran to join us. Hello?
Hey, guys. Apologize.
So I think we can quickly wrap up this session.
Sorry, guys. I'll have to quit from this meeting. I think it's lunchtime for the children, and I think I need to go. But I'll be happy to please send any questions to me. I'll be happy to respond to them offline.
Thank you, sir, for delivering a very interesting and thought-provoking session. We
Thank
were
you.
honored to have you in this conference today, sir. Thank you so much.
Bye-bye.
With this, we reach the end of keynote speech sessions for day 1 of GCAIA 2020. I would like to inform the audience members that paper presentation sessions will start from 1:30 p.m. today, and respected delegates are requested to join the Google Meet links provided in conference schedule. Thanks to all for joining the inaugural session of Global Conference on Artificial Intelligence and Applications 2020. Thank you all. Professor Shomen? Hello?
Yes.
Yes, sir. I think it ends the session today.
Yeah, definitely. The session is going to be ended up here, and we are going for the paper presentation from 1:30, right?
Yes. So we will join you tomorrow again for the second day.
Yeah. And the link of that
Link was posted. The link was posted in the comments box. I had posted the link in the comments box a while back. If you can find that comment, somebody can repost it if needed. Otherwise, Professor Showman may kindly share the links, the PDF of the links once more with the participants. Thank you.
Yeah, definitely, sir. I will do. Definitely, sir. Thank you all. So we are going to close that meeting. Thank you.
Thanks to you all.